Let's talk about using C++ for Unreal. If you're here, that means you probably are either here from a background in an engine like Unity, or you've already watched my Unreal Basics tutorial series, in which we do work with blueprints. If you haven't watched that, go skim through it and see if there's anything interesting in there that you want to see first, because I'm going to skip over a lot of those things here. Let's start by setting up a project now. I'm using Unreal 5.1.1 for this, but most of this should be transferable to both Unreal 5, even some versions of Unreal 4 probably, and up to 5.3 and probably beyond for quite a while. So in this series we're going to make something a little bit like a twin stick shooter, and none of this really works too well for that as a template, I would say. So we're going to have to recode quite a bit. But I do think the top-down template probably is the closest to what we're going to be using. So I'm going to use that as a template so we have a starting point and we don't need to start actually from scratch. And the project defaults we're going to set to C++, because we're going to be writing C++ code. Everything else doesn't matter that much. I'm going to call this CPP tutorial basics, and we're going to create the project, which will take a little moment. While that is setting up, I want to show you the IDE that I'm using. That's Visual Studio Code. I will leave a link down below in the description to where you can download it, because I'm actually using this Unreal Engine 4 snippets plugin, which I can highly recommend. It says Unreal 4 snippets, but it all works with Unreal 5 as well. And that allows you to make some things a lot easier. Having all these macros that would usually be kind of bothersome to work with. Oh, apparently it also has a set timer one. I have never used that one, but that's good to know. So in Visual Studio, go to your extensions and look for Unreal Engine 4 snippets and just install that to your IDE. And just as I finish explaining that, the project starts up. So let's go into the editor preference real quick, because we want to make sure if we type in source code editor, that it's set to Visual Studio Code. If you have any other IDEs installed like Visual Studio or, I don't know, C-Line, don't even know when I would have installed that, you want to set this to Visual Studio Code, because that's usually what I like to use because of that plugin. And now we can see we have a project file like we used to, but we have a folder with C++ classes. And if we open that up, and we can see we have a player controller and a game mode and a character. So let's open up that character, and when that opens up you might get a pop-up like this, and you just say yes, I trust the authors, and that opens up our first couple of files, which we'll talk a little bit more about how these files are structured and what they're doing in the upcoming parts. For now though, you want to make sure that everything here doesn't give any errors or anything, and if there is any errors that you don't really know what to do with, if you haven't done anything as far as adding any code yet, it's most likely because you need to build your Visual Studio project file. So you can just right click on the U project file here in the left hand side. If you don't have this Explorer, it's this icon up here that will collapse it. And we can reveal that in our Explorer. If you right click on that in your Windows Explorer, you can generate Visual Studio project files. And that will just regenerate any missing project files for Visual Studio. So if you've just added a new C++ class, sometimes you do need to do that. It should do it automatically, but for me it oftentimes just straight up doesn't. And let me zoom in a little bit here, just so you can see what is all going on. Now, we're not going to do any actual coding here yet today. We're just setting up the project and going over some of the most basic features, one of which is going to be live coding. Because unlike what you might be used to in Blueprint, where you are inside the engine, inside the editor, making all of your code, we're writing our code in a separate program. So anytime we want to apply the changes we have made, we need to rebuild the engine. And that is a very lengthy process, because that would require us to close down the engine, build, and then reopen. And that would be very annoying. So luckily, there is something called live coding. Going back into the engine here, if we go into the project settings, we can look into live, maybe that's in the editor preferences, I always get those mixed up. Live coding, it is in the editor preferences, so we can enable it. We can also disable it if we really don't want to use it. But let's say that we want to just add a new variable to our tutorial basics character. We can just add a float, and we'll call this test float for now. And don't worry too much about what I'm doing here. We'll talk about that in a later video. But I'll mark it as a U property that is visible anywhere. In order for this test float to be visible for us in engine, we need to now use live coding. So if we go back into the engine here, we can see this little icon, which you can't see actually. So this little icon here in the bottom right, it recompiles and reloads the C++ code for your game on the fly. So if I press this, it will start recompiling everything, and I misspelled visible anywhere. So let's try it again now that I have that fixed. And it will recompile the changes you have made, and after it's done all that, which will take a minute, especially the first time, it will take a minute because it needs to compile a lot of stuff. After this, it will only recompile the changes that you have made. And now if we go into our top-down, our blueprint that is based on that C++ class that we've just edited, we'll be able to see somewhere in here, let's open the full blueprint editor real quick. We have a test float which is visible. It's only visible, we can't edit it because I marked it as visible anywhere. Again, we'll do a separate video specifically on UPROPERTIES because it's something that I really, really need you to understand, but not for right now. Another way to do that is going back into your code editor here, your IDE. Let's copy this over and say we want test float 2 as well. A shortcut that you can do while inside Visual Studio Code, so you don't have to go back to Unreal and press that little button that's very hard to hit sometimes, especially on a bigger resolution screen. You can also press Ctrl-Alt-F11, and that is a shortcut that will recompile and live code everything as well. And now we'll be able to see we have test float and test float 2. You'll also know, by the way, this is very useful because I'm using this specific capitalization technique where we capitalize the first letter of every word in the variable. It automatically puts in spaces for us there. So that makes things just a little bit more readable, which is quite nice. Now, let's close the engine and restart it. And you will see there's a little bit of an issue there. Now that I have restarted the engine because I just stopped working for the day, or maybe I managed to crash the engine and it restarted on its own, I don't have the two floats here anymore. And that is because live coding only, for lack of a better term, patches in the new additions that you've made into your current session. So it's not actually recompiling the engine as a whole. And there's two ways to go about fixing that. Number one is, I think, in the editor preferences. Maybe this one is in the project preferences. We will see. In your editor preferences, you can tick the force compilation at startup, which will force the source code to compile into your engine anytime you start the project, which can be very useful to fix things like this, because that way, whenever you start up the project, you will have the latest version of whatever code you have written, because it will always compile. That said, if you have an error in your source code anywhere, so let's say we misspelled this and we wanted to make a float instead of a float, that's not going to compile because this is a data type that does not exist. And if you want to compile the engine every time you start up a project, because of this error, the engine itself is just not going to start. So while it is very useful to compile the engine upon startup every single time, it's also quite tricky because it might lead to you not be able to open your project in the first place. Of course, you can still access all this code because it's in separate files, but maybe you don't want to bother with coding, you just want to play around with particle effects. Well, that's tough luck because you need to fix your compile errors before you can even do that if you enable that option. So I personally don't like turning this on, but it is there if you think you are brave enough to deal with that. The other solution is coming up here, and let's just put that back. Turning the engine back off again. This is very important. You can't compile and build the engine while it's running, so you need to close it down. And then with Ctrl, Shift, and B, we get a build. So we can build our game and our engine. And we'll look for our project name, editor, Win64 development build. That is the one you want to build. So if you just press that, it will start building the whole engine. And now after this, when we open up the engine again, it will actually have all of these changes baked into it. And the wonderful thing is, if I press Ctrl-Shift-B again now, it is on top here in recently used tasks. So I can just keep doing this over and over again without having to look for it every single time. So now we have the engine back open yet again. Let's go into this blueprint. There's no live coding enabled at all at the moment. So let's see if I look for our test floats. They both exist anyway, because we've built the entire engine. So those are some of the more basic things that you need to know about just how the IDE and the engine interact with each other. We're not going to go into any actual coding today. Next time we will talk about making classes and how and when to use C++ and how and when to use blueprints, because both of them are going to come together to make a very smooth and nice development process for us all. Let's talk a little bit about classes and how we're going to structure things to make them make sense, because what we're making here as an example project is a simple twin stick shooter, and I just downloaded this free asset with this character so that we can have something a little bit more appealing to look at than the default mannequin. And in the end, what we're going to need is we're going to need one class for just magic character, which will inherit from the normal character class. And then from that class, we're going to split off our player character and our enemy character, which those two will have slightly different things that they need to be able to do. But they both share quite a lot of things, like being able to carry a weapon and being able to shoot with that weapon, or maybe the weapon itself will have the shooting functionality. We'll see about that in a moment. But let's actually get just started with making that first class, shall we? So we can go into our C++ classes and we can make a new C++ class. We're going to be a child of the character because we want everything that the character has, and we're going to add things on top of that. Then we want to choose whether or not we want a private or a public class. Usually we just go with a public class because we want to be able to access things. And we'll call this base character, let's call it base magic character. And then we will create that class, which will create a new header file and C++ file. We'll remove the tutorial character that we have made before. And if you've seen my last video, you will note that, hey, we have some errors here already. I haven't even done anything. How does that happen? Well, if you've seen the last video, you know the answer to that is we're going to open the file explorer for our U project, and we simply need to generate Visual Studio project files. It's very annoying. I do believe that this is probably maybe something that's just wrong on my end, which I still haven't fixed because it's one of those things, right? It's a 5-second fix every single time you need to do it, and it's a 5-minute fix to fix it forever, so you never really invest that time. I really should. If you have the same problem, at least now you know how to fix it. Okay, let's talk about header files and C++ files, because you might not be used to working with that. This header file is where the actual class lives. This is where we declare everything. So you can see we have a function here with the same name as our class. This will be the constructor. We have a function here for begin play. We have a function for tick, and we have a function for set up player input component. We don't actually really need that, but we're going to keep it because why not? But you might notice that these are only a couple of lines and there's no actual code here. And that is because our CPP file is where the actual code is getting implemented. So this will include that header file, and that's just more or less saying that, hey, everything that's in this header file, act as if that's just copy pasted on the very top of this CPP file. So we have access to everything that's in this header file, that mainly being the actual class that we have here. So we have the class name, a base magic character. You'll notice that I didn't add that a myself. That's something that the engine did for us. And that is because of the standard naming conventions that the engine uses. Anytime you're making anything that's an actor, and a character is a pawn, is an actor, it's going to add a in front of it, just so that you can at a glance see, oh, this is an actor and this is something else. So the class is called a base magic character. Then we have this double colon, which is, if you're used to C#, In C# you have the dot operator, right? If you have a variable, let's just very quickly make a f vector, which is what a vector is called. You'll note that this doesn't have an a in front of it because it's not a actor. I don't actually know what the f stands for, if I'm being frank with you. You might be used to using the dot operator to get something out of a variable or whatever. Well, if you're using a static class like this is, in C++ you're using a double colon. So what we're seeing here is more or less just we have this class, and inside this class we have this method, and that is what we're implementing here. So for the constructor, everything that it's doing so far is just setting the can ever tick, which just really enables or disables whatever is in this function to being true, because that will be the default for most actors. And then the same thing we have here, we implement the begin play, which runs when a character is spawned in or when the game starts. Tick is just your update loop. This will run every frame. We have a delta time in it as well. And then we have a setup player input component as well, which sets up the player input component, which we don't really need for this character because this is going to hold all the general code that needs to be shared between the player version and the AI controlled version. But it just adds this by default, so that'll be fine. One more thing that you will note though is that all of these other functions, begin, play and tick, have a super tick, which sounds very impressive and very interesting, but all that this is doing is it's saying whatever is in this function in the parent class of this class, also run that. So we have this base magic character, which inherits from the public class character. And if we hover over that and we press F12, we go into the header file for character. And then we can go a step deeper into a pawn, and then we can go into a actor. And somewhere in here, there is the first instance of the tick function. I think it might be on a actor. So let's see if it is anywhere in here. That's way too much to look through. So I'm not going to look through it, but just believe me, somewhere in here is a tick function that our character is doing because we do this super thing. This will make a little bit more sense in a minute when we implement our own functions and we don't need to go digging through the literal thousands of lines of code that the engine has already written for us, because that can get very confusing. So let's make a function for ourselves, right? Because what we need is we need a function to shoot. I'm not actually sure how we're going to do the implementation of it yet, but let's just make that function. We have three sections here, public, protected, and another public. This is just the availability of whatever is under that section until you put another one of these keywords down. So we have public, which is accessible to any other class that has a reference to an object of this type. We have the very well-known private, which is not in here, but I added it myself now, which is nobody can access anything about this other than this class itself. Then we have protected, which is kind of a middle ground between the two. Other classes can't access whatever is in protected. So it's kind of like private, except if you make a child class of base magic character, which we're going to do eventually, we're going to make player and enemy classes out of this. Anything we put into the protected section will be able to easily be accessed by the children of this class. Where anything that we put in private, not even the children of this class will be able to access it at all. So we're going to put this function that we're going to make in the protected section. I'll just make a void shoot function, and I don't really think we particularly need any parameters for that. And the easiest way to implement that is just to right click on it and create declaration/definition. You can also make it in the CPP file, and then it will add the declaration in the H file. It works both ways around. It might take a little minute to actually do that though. And now we have a method that we can actually start putting code into in our CPP file. So whatever do we want to do when we are shooting something? Well, when we're shooting something, I think what we want to do is we just want to call a method on a weapon. I think having the weapon itself worry about all of the shooting makes the most sense to me. So let's make that class as well. We've already made a class, so pause the video now and try to make the weapon class and also a bullet class all by yourself, and try to create a function on the weapon class that is also just called shoot. Okay, I'm assuming that you're done with that because we're going to be moving on. I will, however, just do them real quick for you. What we're going to do is the weapon will be an actor. I didn't specify that. I hoped that you would be able to figure that out on your own. If you didn't, no worries. And I'll call this base weapon. And then we'll also make another actor again, and we'll call this base bullets. Got to regenerate my project files because, again, Visual Studio Code has just been a little bit weird about it. And then in our base weapon header file, in the protected section, again, we're going to put a void. And this one I'll call weapon shoot, just to make sure that I understand when looking back at this, what is the difference between shoot and weapon shoot? Because otherwise you might get a situation where we simply run this function, which is called shoot, and in that we run another function called shoot, which is just kind of confusing. So we'll call this weapon shoot to make sure that we actually properly understand what is going on. And for now, we're just going to leave this empty as well. We're going to implement some of the code itself in later parts. I just want to walk you through to the very basics right now of how to set up these header files and these CPP files and how to work with them and how they themselves function. And to complete all of that, what we're going to do is I'm going to go into this public folder here and go to my base magic character. And I'm going to right click on that and create a C++ class derived from base magic character. And we'll call this base player character. And I will make another one and we will call that one base enemy character. There is a chance that we don't actually need a separate class for the enemy character, but I like just making them. If I don't end up adding anything into this C++ class that I particularly need for the enemy, I can always just turn things back and make the enemies just use the base magic class instead. But it's nice and easy to have this ready to be able to code in if there's anything that specifically only the enemy needs to be able to do. Now, we have the C++ class for our base magic character, which we then have a player character version of, and that we're going to make a blueprint class based on. So the very final step, the very final class we're actually going to be using in the game is going to be a blueprint class, because that will be open to us in the editor to change around values without needing to rebuild every single time we want to change a value, because that would be highly annoying. And we can also maybe, if you wanted to, add a little bit of extra blueprint scripting on top of that for things that might be particularly annoying or difficult in C++ to do. So let's create a blueprint class and we will name this one just BP player. And that creates a blueprint class as we know and love it. So we can open it up and we will see just a normal character that we have. So let's put in the mesh component here, our wizard, and then we'll put that in the proper position and scale in a moment. For now, I'm just going to use a idle animation for the wizard because I don't have an animation blueprint for him yet. We'll make that at some point. I might make that off screen, to be honest. And I think we have some time for one last thing to do. And that is we're going to add a component through C++. I think that is something that really fits in with what we've talked about here today. And that's a nice last little thing before we end off this video. So let's close a lot of these classes that we're not using at the moment because I'm zoomed in way more than I'm used to. And it's kind of a mess up here in this taskbar. So let's open up our base magic character. In here, we can declare in the, I think the protected section would make the most sense. Maybe private would work as well. What we're going to declare is we're going to declare a child actor component. And here we need to figure out what actually is that called. And that is where the Unreal documentation comes in. So looking through the documentation, you'll be able to find the child actor component. Because it's not an actor, it's a component. It might be called a child actor component, but it's because it's a component that holds a actor. It doesn't start with an A, it starts with a U. components generally start with a U, and a lot of other things as well. So let's try to add that, right? We can add a U child, if we type it out correctly, actor component. And we need to add a little star after it because it's going to be a pointer to that component. We'll talk about pointers maybe in the next video, maybe the video after. I'll explain them pretty soon because they are pretty important to understand. A very brief rundown is that this is a variable that's going to just, well, literally point to another variable. And that is a memory management optimization thing for C++. Let's call this weapon. Now we have a pointer to that, but how do we actually add this into our blueprint? Because just adding this isn't going to do too much, but we can make this, again, I'll talk about this in probably the next video, make this a U property so that we can actually see it in Engine, and we mark this as edit anywhere. Still, this won't really do anything because it's not initializing or not setting up any components. We need to do that in the constructor, and now this is throwing an error. Why? That's why. So let's go back into that CPP file that corresponds to that header file and say our weapon is equal to something. And now we're going to need to create the component. So the method for that is called create default sub-object, which is creating a default sub-object, a object within an object, so a component for our actor. And we need to give it within these angle brackets the type that it's going to create, which is a U child actor component. And then in these parentheses, what we need is, we can actually see if we hover over this, there's 4 overloads for this. In these parentheses at the end, we need to put in the name of the component. So we can do that with the macro called text. And then in the parentheses after the text, we just type out the weapon. It's as simple as that. And then we end with a semicolon. This will add a child actor component to our base magic character. Now, we want to have this child actor component be parented to the mesh because it's going to be in one of their hands. And if we just live code compile right now, we'll be able to see in a second. So now in Engine, we can see we have a weapon, which is a child actor component in which we can put a child actor class. So let's make a blueprint class real quick for the weapon. So create weapon here, and we'll just call this BP default weapon. The weapon itself has nothing in it yet. We'll get to that in a moment. But now we can give this a BP default weapon, which I misspelled, it looks like. And now this weapon just exists at 000 in this actor, which is not ideal what we want. What we want is we want to parent it to the mesh. But since we created it in C++, we can't just drag it onto the mesh. So we need to parent this to the mesh in C++, which is remarkably easy. Because after we create the default subobject, what we can do is we can say on our weapon, we use a little arrow because we're using a pointer. We use an arrow instead of a dot operator, like you might be used to in C# or Java or whatever. And then we can set up attachments. And what this does is this takes in another scene component and potentially a socket name. And the scene component that we're going to be attaching this to will be our mesh. And there's a function on the character itself that just returns a pointer to the mesh. So now if we live code this one step at a time and we recompile this as well, sometimes it's a little iffy with live coding. So what you can do, which I don't recommend you do too much, but if we just change this to like actor real quick and then we reparent it to base magic character, now we have lost our mesh. So it loses all of the information that you put into it. So again, it's not really something you want to do, but for right now, for just showing you, we can see that the weapon is actually parented to the mesh now because of what we just did in C++. Now I'm going to actually Ctrl-Z my way back into this. And even now, you can see that still works. So it's a little bit of an iffy way of doing it. Don't do that yourself because it does have the potential to break things. But even now, we can't change the parent socket because, again, that's something we need to do through C++. So let's take a look at this mesh here. and take a look at the sockets. We have a socket called weapon sockets. So we'll copy that name over, and simply in our C++ code, the second parameter here will be, just as we did before, we do a text in all caps, and then we simply pass in the name of the sockets. And now if we recompile that, I ended up having to rebuild and restart the entire engine for it to take effect, which with this kind of stuff does tend to happen. So if it doesn't work right away for you, try to do that. But now if I look at the weapon, it's inside of his hand, because that is where the socket is located. So now I could put a mesh on this weapon class, and if it displays that mesh, it will just have the weapon in his hand. So that's a little bit of a challenge to you. Pause the video now and try to find out through the Unreal documentation, which you can just find through Google, what you need to do in order to add a mesh component. I'll give you one little hint. It is not going to start with an A. It's going to start with a U. And from there, it should be pretty self-explanatory what it is called. Try to figure out how to add that on your own. And if you can't figure it out, we're going to go through it step by step in a quite quick tempo after this. All right, let's go into the base weapon.h. And in the protected section, I'm going to add a U static mesh component, which we can see in the Unreal documentation right over here. So that is the component that we're going to be adding, and we'll call that weapon mesh. Then over in the corresponding CPP file, we're going to go into the constructor, which again is the method with the same name as the class itself. And we'll say weapon mesh is equals to, and I made a mistake, because you don't want to make a uStaticMesh component. You want to make a uStaticMesh component pointer. So add the little star behind it. But just for shits and giggles, I'm going to show you what happens if you forget that, because this is something that you might worry about. When do I need to use pointers and when do I not need to use pointers, and what even are pointers? Again, we're going to get to what pointers are in the future. But for now, if you mess it up and you try to use a normal variable, where you should be using a pointer, the engine is just going to call you out on it. So let's create default sub-object here of the type uStaticMesh component, and we'll call that one weapon mesh, as easily as that. Now, the semicolon needs to go at the very end. There's going to be a little squiggly under this equal sign, and that is because we can't convert a static mesh to a static mesh pointer. So if this happens and you're like, but everything about this seems right, everything about what I've written here seems correct, what is the issue? The issue is most likely, and in this case definitely, the fact that you've got to make it a pointer. So when we make this a pointer and we wait a second, because VS Code can be very slow in updating this kind of thing, the error disappears, and now we have our static mesh here as well. So let's live code compile that. We can open up our default weapon, and when we look at that, we can see a static mesh component exists in here, and we can't edit it because I forgot to make it a edit anywhere UPROPERTY. So let's just copy that over from here. Again, we're going to go into everything to do with UPROPERTYs in probably the next video. But as we are going through this, I'm sure you can try to piece it together pretty well what it does and more or less how it works. But now that we have added that UPROPERTY, we can actually edit the details here, and we can find the weapon for the wizard, which I'm not entirely sure actually what it's called. So let's add this one, which will then have added it to our character here. So now we have a character that has a custom component on it, or at least a component that we added through C++, which is an actor that has the component here that we added again through C++. So that's how you set up your classes and work with all that kind of stuff in C++. There was quite a lot here to be talking about, so do feel free to go back through this video a second time and just look at everything a little bit more closely now that you have the full context. Next time we're going to have a bit of a shorter video where I just highlight UPROPERTYs for you, and after that we're going to have another shorter video for talking about pointers. Again, it's not that complicated, but I want to make a dedicated video to it. After that, we're actually going to get finally into the proper coding of things. At that point, you should be relatively familiar with all of the quirks of Unreal and C++, and we can start writing some code to make the project that we want to make here. Let's talk real quick about UPROPERTIES and UFUNCTIONS, because that's something that you're going to need to use quite a lot. If you have some C++ code here, which we do, you can see I've added some things called UPROPERTIES to some of my variables. And if you're used to working in Unity, which some of you might be, this is kind of like adding serialized field to a variable. It just makes it available for you in the editor and in Blueprint. But it goes a little bit deeper than serialized field usually does, because you can see I can say this is a UPROPERTY, which will simply expose it to the reflection system, which makes C++ and Blueprint able to talk to each other. But then we actually have to specify a couple of properties to it. In this case, that would be edit anywhere, meaning that if I go into the engine, I can edit it in this Blueprint defaults. But I can also, if I pull this actor into the world, because it's set to edit anywhere, I can also edit it in the details panel here. If I go back to my UPROPERTY and I change it from edit anywhere to edit defaults only, and I recompile real quick, now you will note I can't actually edit the static mesh here anymore. But if I go back into the Blueprint itself, everything is still editable because the UPROPERTY is now set to edit defaults only. Well, there's quite a lot of specifiers that we can use in order to specify what we want our UPROPERTY to be able to do. And there's an entire page about this on the Unreal documentation, which I implore you to read through. I'm not going to talk about all of them right now today. But maybe even more importantly than UPROPERTY is UFUNCTION. You could argue it might be as important, but we can make a UFUNCTION in much the same way, and that one we can assign as Blueprint callable. So we can call it in Blueprint. So we have our base weapon class here. If I compile that and I go into the event graph of our Blueprint version and on begin play, for instance, I can now say weapon shoot. That's the function that we just made in C++ last time, is now accessible to us from Blueprint. And that is only because I made this UFUNCTION Blueprint callable. If I remove that, try as I might, weapon shoot doesn't exist in my options for Blueprint because Blueprint has no idea that this exists. It doesn't need to know every single function on every single C++ file at all times, because you can make a lot of functions that a Blueprint user, like a end designer or whatever, is never actually going to use, and you don't want to just throw everything at them. So only when you want a script in Blueprint to be able to use a function is when you mark it as a UPROPERTY and you make it Blueprint callable. Now, let's say we have this weapon mesh here, but we also want to have something like a float, and we make that edit default only because we want to be able to edit it, and we call this the damage, right? Then we compile, and then we want to use that damage in something in Blueprint. Well, I'm going to just spoil that for you. That's not going to work. We have our damage value here, and we can edit it because we set it to edit anywhere. But the moment we want to actually get our damage, like get damage, it doesn't exist in Blueprint because we haven't specified that we need to be able to read and or write to this variable in our Blueprint graph. We can only edit it in our details panel here. So going back here, we can add more than one specifier into a UPROPERTY. So we want to be able to add it in the defaults only, but we also want to be able to Blueprint read only. Now, in that Blueprint, that will allow us to get our damage variable because we set it to read only. And as you'll be able to note, we set it to read only. So if we want to try to set our damage, that doesn't exist. We can literally only ever get it. Which again, if you're a programmer working in C++ and you have some designers that are using Blueprint and you're like, okay, you can read my damage value, but please keep your freaking hands off the actual value. I don't want you to change it. you can do that. You can just make it read-only and your designers will be entirely lost not being able to change it by hand. And of course, you can also make it both readable and writable by just making the blueprint read-write. And now we can also set our damage, and all the designers are now very happy and all the programmers have just gotten a heart attack. While we're at it, I'm going to also make a quick function here that is something like a float calculate damage, something like that, right? Let's just spell it out properly. And let's say that takes in a float for the damage and a float for the multiplier. This is a function that I'm actually not going to use. I'm just putting this in here for an example to show something. Because we can make this ufunction blueprint callable, that's all fine. But as you might have noticed, our weapon should, if we try to call that weapon should, that is one of these execute nodes. And that is fine, but what if we want to do something like get player character, one of these type of nodes, right? That doesn't need any execution pins, it just returns a value when it's plugged into something. This is called a blueprint pure node, and you can make those inside of blueprint as well, of course, but the way you do that in C++ is just make it blueprint pure, and it doesn't have an implementation, so that's not actually going to do anything. So let's just simply return damage multiplied by the multiplier. Again, just as an example. And we have a conflicting name here, so that is my bad. Let's just add an underscore there to fix that conflicting name. And now if we type calculate damage, we get a blueprint pure node where we can put in the damage and the multiplier, and it will return a float with the actual damage. It's a very simple case of doing this, in which case you might as well just use a multiply node, right? It's as easy as that. But you can make a lot more complicated calculation and logic in a node like this and just make it easily accessible to your blueprint designers. And again, go check out this page to just read through what all these property tags can do for you, because it is very good to be aware of these. But these ones that I've shown you so far are the ones I personally end up using the most. That is added defaults only, added anywhere. We have visible anywhere or visible in the defaults only. We have blueprint read write, blueprint read only. For functions, we have blueprint callable and blueprint pure. Those are the most used ones, and you're going to be using those 99% of the time when you're making something a U function or a U property. Those other ones also exist, and it's good to be aware of them, but I just wanted to show you what this U property and U function stuff is all about. So now that you're aware of that, next time we're going to talk a little bit more about pointers, and then we're going to get into the meat and potatoes of actually making. Okay, I'm going to try to explain pointer variables to you, and you're going to have to stick with me because it's kind of a mess to explain. The best way to really get a feel for this is just to start coding and working with it, but it's good to have heard all of this information that I'm about to tell you before you actually get to that. So we have two types of variables in C++, which is a gross oversimplification, I am aware. But we have a normal variable, which is just a data type, like uStaticMesh that we have here, or a float, or whatever you want. And we have pointers. And pointers point to wherever the memory address is of another variable. So what we can do here is, if we have, I'm just going to use some f vectors as an example. We have a vector, and we'll call that the location. That's just the location in the world for this actor, just as an example. Then we can also make, if we really wanted to, which I also need to capitalize the V in vector, we can make an f vector pointer, which you just do by adding a little star after the data type here. And we'll call that a location pointer. Now, that location pointer is just a simple, very cheap variable that will not take up too much of your RAM. So if for any reason you need to reference this variable in a different location, you can make a pointer, and instead of having to copy over the entirety of everything to do with this f vector, or something that's a lot more heavy, like your entire player character, which might be entire megabytes of information, instead of having to copy over all of that data into a different place in memory, what we can just do is make a very simple variable here that will point to the place where this is stored in memory. That way we can access it directly rather than making a copy. Because if we try to, for instance, use this in a function, what it will do is it will make a copy of this variable, use that in the function, and then return yet another copy. So instead, if we make a function that takes in a pointer, it doesn't need to make a copy, it can just use the actual original data. And especially if you need to change something about that data, if you have a function that makes a copy of this location, then changes something and returns a copy, the original location vector isn't actually going to get changed. For that, you're going to need to actually point towards that specific place in memory. So, for example, let's just make a function increase vector, something like that. And that's going to take in a f vector, vector to increase. Let's create an implementation for that. So now, and I can't really show you this in here. I probably should have just made an empty C++ file. Well, that's a little too late now. We can still do that, maybe. Just believe me when I say that this works the way I'm telling you how it works. Okay, fine, good. Because if we now take our vector to increase, I'm just going to copy it over because I'm lazy, and we try to add to that a f vector of just 1, 1, 1, for instance, you might think, okay, we can pass in a vector here, and then it's going to add 1 to the x, the y, and the z for our vector. And no, that's not how that works at all. Because when you call this function somewhere else, like in begin play, like increase vector, and we had a member variable here just called location, that's not actually gonna do anything. Because what it's gonna do is it's going to call this function, it's going to use a copy of this and increase that copy, and then by the end of this function, the function is done, so anything that was created in this function is going to get deleted, and nothing actually happened. You just wasted some computer resources with no outputs. Now, what we can do instead is, instead of passing in a location directly, we will pass in a vector pointer. So let's change this to a vector pointer. And now we need to pass in a pointer, which is a memory address. For that, we need to change a couple of things. First and foremost, we're not going to pass in the location, we're going to pass in the location pointer. And then we can't add a vector to a pointer because the pointer is not a vector, obviously. So what you can do is you can put a star, much like you have a star at the end of your data type to make it a pointer. If you put one at the front of your variable name, that dereferences things and makes it go from a pointer back to it, treating it as if it's that variable. And now this is actually taking in whatever vector we are pointing to and adding 1, 1, 1 to it because we're using a pointer. But how do we give this pointer a value? Because now we're declaring a location pointer variable, that's fine, but it doesn't have any value. And if you run this, it's actually going to crash your game because it's referencing a null pointer. And if it's a null pointer, meaning a pointer without any information in it, yeah, the engine or your computer in general does not like that. So we can give this a value by saying it's equal to the address of, which is this ampersand sign, this location variable. And you will see that works entirely fine. So we make a f vector pointer and we say this pointer is equal to whatever memory location this variable is at. So in theory, for what we're doing here, we can entirely skip making this variable as well, because you can just do this in your code right away. So instead of passing in the location pointer, what we can do is we can just pass in the f vector location, but we just pass in the address of location. And this will now pass through the pointer, which is the memory address of this variable, into this, and it will work perfectly fine. Hey there, this is me in the middle of editing this video, and I forgot to mention one relatively important thing. And that is, if you're used to any sort of programming, this is my own code for my own game that I'm scrolling through right now, you might see something that seems slightly weird to you. And that is, usually if you have a variable, so I'm just going to, again, make a f vector here, which we'll just call vector real quick. You use a dot operator to get anything that is stored inside of that data type, be it the x, y, z coordinates or any of the methods that you can find on it. But the difference being is if you are using a pointer, so if we make a pointer out of this and I use the dot operator, you will see it turns it into this little arrow instead. And that is because Visual Studio Code is nice enough to do that for me. Not every IDE will maybe do this, so it's still good to be aware of this. If you are working with a pointer variable, you don't use a dot to get something out of it, you use an arrow instead, which is just a dash and a greater than sign. Again, with Visual Studio Code, that will just automatically do that for you and you don't have to worry about it, but it is something worth mentioning. So now let's get back to the video. Again, if this doesn't quite click for you, it doesn't for a lot of people. For some people, this is second nature and they just right away make sense. If it doesn't quite click for you though, don't worry about it. A lot of people struggle with quite getting this at the start. So don't worry, now that you've heard all this information, as we go along and we do a little bit more coding and we do a little bit more experimenting with C++ code, it's going to start clicking into place at some point. As you're playing with it yourself, you're going to start realizing how this all works. And by and large, like I showed you in a previous video, when the engine expects a pointer, it will just scream at you when you're not giving it a pointer, and you just make a pointer out of it with the ways I've shown you in this video, and the other way around as well. If you're accidentally making a pointer and the engine is expecting something that is not a pointer, it will just scream at you and you can just dereference it in this way, for instance. So you will be fine. You're working in such a tightly constructed framework that Unreal is providing you. You can't really do anything catastrophically wrong with all of this memory mumbo jumbo. It'll be fine. Next time, let's actually dive into some proper coding and maybe we'll make some movement or something. I'm not entirely sure what we're going to do yet, but we're going to do some actual coding now that I've explained all the very much basic things about C++. Let's add some input code because we have talked about the most basic things about setting up a C++ class and how to then connect that up to making a blueprint and how to put that into the world, all that kind of stuff, how to add components to your classes. But now let's make some actual gameplay, because we have this template here in which we can click around, have a point and click movement system, but that's not what we want. I just make this as a template project because it's the closest to what we're actually going to end up using in the end. But this is not what we want. So what we want is we want to move around with WASD, and those don't do anything in this case. So let's open up the code that we already have pre-generated, see how that is built up and how we can change and add to that to make what we actually want. If you come over to whatever your project is in VS Code or whatever IDE you use, you want to look for your player controller. You can also put this code directly on your player character. It really works either way. Player controllers are meant to do this kind of stuff. This will take your input and pass it through to the pawn that you are possessing, which will be your player character. And this way you can very easily switch between characters you're controlling because all of the input is getting registered through the controller rather than directly on the player itself. For some type of games, especially since we're making a twin stick shooter, maybe you want to have multiple unlockable characters, and maybe at some point we decide actually maybe we want to have a ability to switch between characters, right? Maybe we want to make a Mario Odyssey type mechanic where we can capture other enemies. At that point, it's literally as easy as just saying, okay, now we are possessing that one, and all of our movement code is on our player controller. So we don't have to add that same code to a million different classes. So that's why we use player control. Anyway, once you have that player controller, you're going to want to make a function called setUpInputComponents. We'll talk more about virtual and override methods later, but it's important that it's this exact name, because this is overriding a function that exists on the parent of this class. Again, we'll talk a little bit more about that later, but if you get what that means, you'll understand why it's important to give it this exact name. For now, just give it this exact name with this exact capitalization and we'll move on. We have the super setup input component. I do believe we talked about that last time. This just means that everything that's in the parent version of this function will run first, and then we can set up our input bindings. And here is where we're going to make our things move. Because right now it's setting up the mouse input events, which we have an enhanced input component, which is a component that exists on the player controller, which we'll talk about in a minute. That has a function called bind action that takes in a input action, which is a asset that we can make in the engine. It takes in a event type, whether we started this input action, so for a left mouse click, for instance, whether or not we pressed it down or stop pressing it or whatever. Then it takes in a object that is pretty much always just going to be this, and this just means, well, this object. So if you're in the world and you have 20 different instances of a controller, for instance, if you're doing a multiplayer game, this is just a keyword that means that whenever an instance of this class executes this code, it will just refer to itself and not to any of the other instances of it that exist within the world, or any other object for that matter. And then we have a address of. Remember this from the pointer video. This will give you an address of something, a memory address. And then we have a function name with a class. So what this will do is when we start this input action, this object will run this function. Make sense? No? If it doesn't, go back, pause for a moment, think about it, re-listen to what I just said, because this is very important. Because this we're not going to actually use. We're going to put in our own bind actions. But for that, we're going to need to make our functions that we're going to run when those actions are done first. So let's comment away all of this code here, just so that it doesn't run anymore, and do the same thing here. If you're using VS Code, by the way, that is Alt, Shift, and A will comment out all your selected code just like that. It's a very handy little thing. And if you then do that same shortcut, it will uncomment that code again. That will save you a lot of heartache going forward. Do remember. I could just delete it, but this is the wonderful thing about working with traditional code, is you can just comment something out if you're not sure whether or not you're going to use it in the future. Let's make our function. We're going to make a function to just move us around. Just very simple, and we'll worry about animation and stuff later. That's mostly going to be separate from using C++ anyway. So find the corresponding header file, and here we're going to make in our either in protected or private. I'm going to do it in private now because I don't think we're going to make children of this anyway. So protected probably doesn't even matter that much. Let's just do it in protected anyway. I don't really care. We want to make a function called void, and we'll just call this move. This one you can call really whatever the hell you want, because we're not overriding anything. This is just, we're going to be using this function to move around. In that, we'll need a f input action value, and that will take in the memory address of a value. If you keep getting an error here that it's an undefined type or whatever, scroll up to the very top of your header file and see if you have the line #include input action value.h. We'll get a little bit more into includes and header files in maybe the next video or the video after that. Let's create a definition for that. And now we can start coding this actual function. So we're going to need to get a couple of things. First and foremost, we're going to need to get a f vector 2D out of this, and we'll call this the movement vector. We'll set that equal to whatever this value is. This input action value can have a bunch of different types of data in it. It can have a bool in it if it's just a simple button, like the X button. Is the X button being pressed currently? If we map that to it, this input action value can be used to get a bool out of it. But we're going to map this to an analog stick, which means that we're going to get a vector 2 out of it, or a vector 2D, something with an X and a Y value. How far in the X value do we have our analog stick tilted, and how far in the Y value do we have it tilted? So we can simply say we want to use our value and get something out of that. But now we still don't know what to get out of it, and we'll also get a error here. And that is because this is a template function. And in a template function, I think we've used one before, you need to put these little brackets in there, those little pointy brackets. And here you put the type that you want to use with this function. So if you want to get a bool out of this, we put in a bool here. And that will work perfectly fine most of the time. For our purposes, we want to get a vector 2D out of this. So now we have this vector 2D here, which is going to get set to whatever our movement input is. Then we need to add it to the actual character in a movement, because we have a value, how and where we need to move now. But that's just a directional input. We don't have a speed. We don't have anything to tell the character to actually use that to move. So let's do that. We can do that with a function called getPawn. If you're doing this directly on your character, you don't need to do this because you're already on a character, which is a pawn. So you have direct access to this function that I'm going to use. But if you're on your controller, like I am, you want to getPawn, which gets you a pointer to the pawn that you're currently possessing. And then we want to add movement input. This function takes in a couple of things, like the world direction. Hey, we just made a variable for a direction. We can just simply put that in. We want to have a float for the scale value. And this is just a overcomplicated way of saying the speed at which we're going to be moving. So let's make a UPROPERTY value for that. So that's just simply going to be a float called speed. And we will allow that to be edited anywhere, just for ease of use. So now we can put in speed there, and then the last parameter, it's a bool that decides whether or not your input should be added to your movement, regardless of a other bool that exists on your pawn called is movement input ignored. Well, that's pretty self-explanatory. Usually when that is set to true, it will ignore any inputs that you're giving. You can overwrite that with this function and say, no, just bypass that completely. I always, whatever is the case, want this movement input to be added. For our purposes, it's not going to be relevant either way, but we're going to set that to false. Now, we have a little bit of an issue because Unreal is a mainly 3D engine. You can make 2D games in it, but things like this add movement input, it expects a F vector, which is a vector with 3 axes to it, an X, Y, and a Z. And we just put in a vector 2D. So how can we fix that? Well, let's make a F vector and let's call that input vector, and that will be equal a F vector here, so we can pass in that vector 2D that we just made and just add a 0 to the end of it, and that's pretty much all we have to do there. So now we can put in that input vector here and it should stop complaining, and there we go. And it's as easy as that. This is how easily we can introduce movement. So this is the movement function. We still haven't bound it to anything. We're going to do that in a moment. First, let's go back to the header file for our controller and look for the input mappings here. So we have some class. We'll get to that. That's forward declaration. Also, probably in the next video, UInput mapping context. And then we have these input actions, both of which are pointers. You're going to need to add both of these into your own class as well. So you're only going to ever need one of these. This is more or less just a list of the input actions that you're going to be using. And for every new input action that you need, to every new button that needs to do something on your character or whatever, you want to add a new UInput action. So we have set click destination here and set touch destination. For this template, it's also implementing touch screen, which we will not be doing. And we will be making our own real quick here. So let's just copy over everything about this UPROPERTY, add it anywhere, blueprint read only, category is input, the meta is allow private access true. I didn't cover all this in the UPROPERTY video, and that is because by and large, it doesn't matter. You can read up on it on the documentation and it should be pretty straightforward. The only thing that might throw you for a bit of a loop is this whole meta thing, but honestly, I don't really care too much about any of that. And let's call this movement inputs. And now we have a input action called movement input, so let's bind something to that. Going back to our CPP file, I'm just going to simply copy over one of these lines again, because why would I write something that's already written for me? We'll use our enhanced input component, which should be as easy as just doing what happens here, which is an if statement first, just to make sure that nothing crashes. You make a enhanced input component pointer, calling that something like enhanced input component. You can call it whatever you want. And you do a cast checked to the type enhanced input component, and then you pass in the input component variable, which is a variable that pre-exists on the actor class. And with any new Unreal project, unless you upgrade from Unreal 4 to 5, you might need to manually put some settings somewhere in your project, which I don't know off the top of my head. But otherwise, this should by default always just be an enhanced input component as it is. And we can use the bind action, and we will not use the set click destination. We'll use the movement input here, and we will change that from triggered to, let's see what the options are. I think we want to use ongoing here because we want to continuously be moving around. And then on this object, we're going to be running the move function. And when making this function, you want to make this parameter const, which means constant, and that just tells the engine that, hey, this value we're only going to be reading. We're not going to be writing to it. We're not going to be changing the value of whatever this is. And usually that goes very well together with functions like this, where we just want to take in a piece of information, do something with it, but not change it. This is just a little bit of protection that you can build in, and for some functions it expects a const value to go in. And now that we have set that to a const value, you can see any errors that we might have had before, which I did have an error, is entirely gone. So that is how important it can be to implement that where it needs to go. Now, you might say, hey, wait a second, we had a parameter on this function and we're not passing anything through like that. How does that work? And that is because we're using this bind action. Bind action can run functions without a parameter, no problem. As you can see here, we have the set on destination released, for instance, doesn't have any parameters. It can run that without a problem. It can also specifically run functions with a const f input action value reference that we have here. So it just automatically does that for us, which is very, very nice indeed. So let's actually finally remove all of this code here, because I honestly am just getting annoyed by it. And while we're at it, we're also going to be removing the set destination and set touch destination here, because we won't be using that anymore either. The same thing with the FX cursor. We're not going to be using that anymore either. And short threshold press, we're not going to use any of this, which makes this header file a lot easier to manage, really. We also don't need the bottom two here or the cached destination, so we don't need anything in the private section is really what we're getting at here. Which means we also don't need any of these functions, because we will not be using all the input that has been pre-set up. Meaning that these functions here, and I'm actually going to zoom out for this a little bit, because otherwise this will be annoying. We can collapse this, we can collapse this, we can collapse that, and we can delete all of that. And we can also delete that. And then on destination triggered, I almost skipped over that, but guess what? We can delete that as well. And now our whole class fits more or less on one screen again, which is quite nice. We don't need the mouse cursor either, meaning that we don't need this constructor at all for the time being. And look at that, it all fits within one screen again. So now we can zoom in again, so you guys can actually read what the hell I'm doing. Now that we have that all cleaned up, let's press Alt Control F11 for live coding. You can see I was troubleshooting the fact that I didn't have the const in there a moment ago. Sometimes it throws me for a loop too, guys. It happens. And let's go into our project settings and look for our game mode. Our default game mode is the CPP tutorial basics. If we look at where that is in our project, we only have a C++ class of that, and that's quite annoying. So let's make a blueprint class of type all classes, and let's make one of CPP tutorial basics game mode. We'll call this BPGM blueprint game mode, CPP basic. This is all pretty basic Unreal stuff, so let's go through this relatively quickly. Opening up that blueprint, which apparently opened up on my second monitor. We can on the right hand side see all of our defaults for this game mode, and we want to change our player controller class, which we might not actually need to change that. We have a BP top-down player controller class. Let's see what the parent class for this is. Is that already what we... CBP basics player controller. I think that's already the player controller that we just were working on. So let's take a look. Yeah, it is. So we have our default mapping input context, which is an asset that we'll take a look at in a moment. And then we have movement input, which is also going to be an asset. There is 2 assets of that type already made. We'll make a new one in a sec. And then we also, somewhere in here, should have a speed variable. So let's put that to something like 10. I don't know if that's very slow or it's going to be very fast. We're going to find out. Let's look up the location of the default mapping context and open up that asset. We can see it has mappings. It has 2 mappings here, the click and the touch. We're going to be removing both of those. And we're going to be adding our own. And there we can put in these input action assets, which let's make one of those. So in here we have actions. For now I'm just going to simply duplicate it and call this input action movement. You can also make them through miscellaneous and then data assets, and then you have them here in input actions. Let's open up the input action, and here we can see whether or not it should consume the input. Should this action swallow any inputs bound to it or allow them to pass through to affect lower priority bound actions? If that makes any sense to you, congratulations. If it doesn't, don't worry. Trigger when paused. So when the game is paused, should we still be moving around? We definitely should not. Reverse all mappings, and then we get the value type. Remember, the value type that we are using here is a vector 2D, because we're going to be using a analog stick, or might as well use WASD. Then triggers and modifiers we don't need to worry about. With that one made, we can put in our new input action in our mapping context, which we just opened up, so that it knows that whatever we're doing here, it has these settings, and most importantly, has this value type. And then we can add inputs to that. So let's add 2 inputs here, or actually let's add 4 inputs, and that is going to be A, S, D, and W. So let's get back to WASD in a moment, and first add gamepad support, because that is ridiculously easy. Anything you need to do there is add yet another input here and look up gamepad left thumbstick 2D axis. This will just pass through the vector 2D that corresponds to your thumbstick input. It's just as easy as that. You can add some modifiers to this, such as for a thumbstick, it's usually a good idea to implement a dead zone, meaning that it can't go over or under a certain value, which 0.2 and 1 are pretty good deals with that. And then what you can also do is adding a scalar modifier here, and that will allow you to put in something like a base speed. We made that speed variable, and we can change that around if we want to, but this will kind of set a base for the speed. So if we say 50, 50, and 1, because we're only using the X and Y components here, that will give us a base speed of 50. And then when we use that speed setup, I think we set it to 10 before, it will be 10 times this rather than 10 times 1, 1, 1. So for any reason, maybe you want your character to move quicker in the X direction than the Y direction, you can best set that up in here. Now, let's get to WASD, because that is a bit more of a nightmare to set up compared to how easy this is. But if you just want to control a game and you don't want to bother with keyboard and mouse, this is all you need to do. Now, these are just normal keys, which is, for the purpose of the engine, the exact same as pressing the X button on a controller or the Y button on a controller or whatever. It's just a bool value, so 0 or 1. And it's going to put that value into the X component of our vector 2D, because it's just going to take that bool value, which is true or false, but we're putting it into something that has to hold a number. So it's going to turn it into a 0 or 1, and we're going to put it into something that can house 2 numbers. So if we don't say anything about what we should do with it. It's just going to put it in the first place that is available, which is the X component. For the A, that's actually quite fine, because the A and the D are about the X horizontal movement. But the A should move us in the negative direction. So we want to add a modifier to it, and we want to say negate, which just makes it negative. You can also say is player mappable. So if you want your player to be able to remap their keys, we're not going to get into that right now, but this is how you enable that, and that opens up player mappable options, and there's again a bunch of stuff that we're not going to get into right now. Then moving on to the S, this is a up and down direction, so we want to put this into the Y component of our vector, and it's also the downward Y. So it's the downward Y. Obviously, we're going to need to, in the modifiers, add a negation, but is still going to just stuff it in the X component. We don't really want that. So what we want to do is add a second modifier, and we'll use the swivel input axis value. And this is just a modifier that tells the engine, hey, this input is going to go into the Y component. And from there, you should be able to quite easily do the D and the W. Because the D doesn't actually need any modifiers. The D is just positive X. By default, pressing down D will return a value of 1 and it will stuff it into the X component. So we don't actually need to do anything for the D. For the W, we need to not negate it because it's a positive movement direction. We're moving in the positive Y direction. But we do need to add a modifier for the swivel input axis values, meaning that we are going to use that for the Y movement. And now that we have all of that put in, if you need to go back and rewatch all that, do feel free to. It's quite a bit to wrap your head around. But now that we have all of that set up, and we make sure in our project settings that the game mode we just made is the game mode that we will be using by default, and we go back into our player controller and finally add the movement input action to our little array here, that should now allow us to move around. And I did actually end up messing up the directions, it seems like, and that is mostly because we have our camera set up incorrectly. So the easiest way to fix that really is just to go back into our BP player, and since we made an entirely new class, we have to add in a camera and a camera boom because we didn't do that by default. So let's take a look at where that is. Those exist in here, so let's just cut those out and then go into our base magic character and add those into the protected section, then steal them away from our camera boom and our camera here as well, and add them into the constructor here too. We do need to add two include files here, which I'm also, again, we'll talk about that more in the next video. Probably should have made a video about that first, but I wanted to get into actual gameplay. We need to steal away the camera component, one here, and the spring arm component. So let's both of those, cut those out of this file and put those into this file. And then also just steal away these functions. We're not going to talk about those functions at all, really, in here, but we'll just put those into the public section here. This will allow us to use these functions, get top-down camera and get camera boom in any of the children, should we ever need. And now when we open this up, we can see, in theory, anyway, somewhere around here, there's a camera boom. That one we're going to set to have 90 degrees of rotation, minus 90 degrees of rotation. So it's looking at us from the top. And also do make sure that our default pawn class is changed from BP top-down character into our BP player character. This one, because that's the one we've been working on. So now that we're looking at this from the top on, let's just take this as our base and say from here we need to move up and down when we press the W and S keys, and left and right when we press the A and D keys, and obviously that's not what's happening right here. So the best way to just go about doing this is going into our top down, our input, and then change these input mappings to whatever they should be. So when we press the D key is when we're going up. So whatever D is doing right now, that should become W. And as you might imagine, that means that the A should become the S. The S should become the A, and the which one is this? I think this should become the D. And now we can move around properly like you imagine. Still no animation, there's still no aiming or facing into different directions, but at least we've got the input right. This is the most fiddly thing to get right, and we can move around now. So everything after this is going to be remarkably much, much easier. We'll get back to adding some more input actions at a later date once I've explained a couple of things about the engine and coding a little bit more, and we'll be adding a system where we can use the arrow keys to change our direction and start firing bullets in whatever direction we might be pressing. And that will work in the exact same way that we have set up this, but we'll also be using a spawning in of actors, which we first need to make those bullet actors. So we'll get to that first. If you do think, hey, I have all the knowledge to make the implementation of the arrow keys to at least rotate the character around, do feel free to take on that challenge. You might have to look back at the video that we're going to do in the future and change a couple of things around. But hey, if you have a different implementation and it works, you know, if it works, it works. So next time we'll be back. This video has been long enough as is. I have no idea how long the final video is going to be because there was a lot of issues that I had to live debug, like me forgetting to put in that const, and then the whole camera situation was kind of troubling. So next time we'll be back talking a little bit more about those include files, because that's quite important to understand. Last time we had quite the mess implementing the movement here, which was a little bit of a pain, but now everything works perfectly fine and is very easily editable. Today we're going to go over something a little bit more basic, something simpler, but something that I do want to point out and make a specific video on, and that is something C++ related. So let's open up one of our classes. For instance, our weapon. If we want a reference to our player on this weapon, how are we going to do that? We can do this through a variety of different ways. The way we're going to go about doing it right now, possibly, maybe not the most efficient way of doing things, but it does show off what I want to show off here. So let's make a protected variable here, and that will be a variable of type a actor. Actually, let's make it a character, and it will be a pointer, and it will point to the player. Now, this will work fine, but how do we get a character pointer to give this thing a value, right? And we'll do that in our begin play. So if we open that up real quick, we can do this a number of different ways. Also, we no longer need this function because that was just for an example. And there's a bunch of different ways of doing that. But today what we're going to do is we're going to use the getPlayerCharacter function. So we get our player, and that's equal to, how do we do this? There is a library called gameplay statics, which is a bunch of static functions that you can just call, which are useful for, well, gameplay purposes, like getting a player character reference. And the way you can get those is by using a include at the top of our file here. So if we do a hashtag include, we then get all of the potential header files that we can include. Because as you might have noted in experimenting or whatever, not every file here has access to every little bit of information in every other file. If I want to go into my base weapon, for instance, is where we're working right now, just by chance, and I want to get a variable from our base magic character. Like I want to get a reference to the camera boom for whatever reason. I can't do that in my base weapon because my base weapon doesn't know anything about my base magic character. The way to give it that information so that it can use that information is to include the header file. And what this include practically means is it just says, okay, when you're compiling, just take everything that is in the header file that we're including here and just copy paste it on top. Just act as if all that information exists in this file as well. So that way we now have access to that information. And that also goes for a bunch of the components that Unreal itself makes. It doesn't include those in all the files you make, because most files aren't going to need most components. So they don't need to know what those components are and what they can do. But then when you add them in yourself, you need to tell your code, hey, you now have access to the information about this new class. Like the auto-generated character that the template came with, that has a include to the game framework player controller, so that it can use the information in the player controller class. It has a include for the character movement component. It has a include for the capsule component, for a decal component, and so on and so forth. So what we're going to be adding here today is going to be in the Gizmo library, and it's called gameplay statics. Now that we have included this, I can call you gameplay statics, double colon, because we're taking something out of a static class. We've gone over this before, I do believe. And then I can get player controller or character. We're going to get character right now. And that requires us to put in a world context object. That's just putting in any object, really, or anything that is a U object, but pretty much anything is a U object if it's Unreal specific. And that's just going to look at, hey, what world do I exist in? Generally speaking, you probably only have one world, but if you have more, it needs to know what world you have. So you can just pass in this. You just want to get the world that this object is inside. And then you want a player index. Now, this gets a little bit tricky. For single player games, this is just always going to be 0. Just always going to be player 0. If you have a multiplayer game, if you just pass in 0 here, it's always going to get you player 1. That's not ideal if you want to get a reference to player 5. At that point, you would need to pass in 6. So you need to make a variable to do something like that, and things get a little bit more complicated. But we're just focusing on single player games here. So this is the way you get a reference to a character pointer here. Just you gameplay statics, player character, this 0. And now when we start a game, our weapon will now have an easy way to reference the player that it is on. And you will see if I remove this include, by the way, and I wait a second here, VS Code is going to scream at me because it suddenly doesn't know what gameplay statics is anymore because it doesn't have that include file. Either way, this is a really, really bad way of doing things because of what I explained before. Get player character, you need to pass in an index, and if you don't know what that index is yet, you can't pass it in. And you wouldn't know at this point. So if you planning to make this a multiplayer game or want to have the option open to you in the future to add multiplayer compatibility, you're going to need to go through a lot of code and get rid of all this stupid shit. So we're going to actually remove that and show you the better way of doing things, which also will mean that we need to use an include file somewhere else. So in our base weapon, what we'll do is we have a character player, and then we'll also make a void function here, set player pointer, something like that, which will take in, and this is gonna fucking blow your mind, is going to be a character pointer. Wait for it, pointer. We're going to point to a pointer, and that is a little weird, but stick with me here. You'll see why in a second. And we'll call this player pointer. Let's make the definition for that. And there we can just say our player is equal to the dereferenced, I don't know why this suddenly just got converted to player, the dereferenced player pointer. So we have a pointer to a pointer. When we dereference that, that just becomes that original pointer again. If you don't know what I'm talking about, go back, watch the videos about pointers with this context. You can point to pointers, which is a little mind-blowing at first, and generally speaking, it's something that you don't want to do, because otherwise, if you have a function that then points to this, you're going to end up with a pointer, and so on and so forth. But for right now, this will work just fine. So this way we can set this player pointer through a function on this thing. And then when we go into our base magic character here, we want to go into our begin play. And here we have our weapon somewhere. I don't recall exactly what we called that variable. So let's look through here. Somewhere around here, that should be child actor component weapon. That makes sense. I actually named things the way they should be named. That weapon, we need to get a pointer to specifically what type of actor it is. And here we also get into something else that I am going to cover in this video, and that is casting. If you have seen my blueprint tutorials or if you've experienced this kind of stuff before, this should be pretty self-explanatory, but I'm going to go over it pretty quickly anyway. So we have our weapon, and that weapon has a function on it called getChildActor. So we have our child actor component, which is a component, and that component has a pointer to the actual actor that it spawns in. But there's a little bit of an issue with that, and that is that this is a pointer to just a regular old actor. This could be literally anything. This is just an actor. So when we make a variable out of this, we can only make an actor variable out of this, right? Let's say we want to make a character out of that. It's going to scream at us because you can't just say, hey, this character called, let's say, character, without spelling it out fully. You can't just say, hey, this character is going to be this actor, because they're not the same type. An actor isn't a character. A character is a child of an actor, but you can't directly put these into each other because that's just not how that works. So what you need to do instead is you need to get this actor and cast it into a character. And all that means is that it's going to try to put the actor into whatever class you're casting to. And if that succeeds, so if the pointer to this actor points to an actor that happens to be a character, that cast will succeed and it will create a variable that points specifically to a character. And now suddenly you will be able to put that into this. So the way you do that is you type cast, then these pointy brackets, and then you type in what type you want to cast to, which will be a character. And then you put in a pointer to whatever you want the variable that is going to get cast, in this case that will be the child actor, to be. And now you see it stops screaming at us because it's no longer trying to make an actor directly into a character. What it's doing is it's trying to cast that into a character and then set that to whatever this variable ends up being. Do be aware, if this fails, this will become a null pointer. And when you try to use it, it will crash your game and your engine. So whenever you want to use this, it is advised to put in an if statement and simply just if and then the variable name. We'll check whether or not this is a null pointer. If this is a null pointer, whatever is in these brackets now will not run. Well, that was a whole tangent explaining casting, because we're going to need to cast to the base weapon. So instead of a character, what we'll do is we'll cast to a base weapon, and we'll call that weapon pointer, and we will cast to a base weapon. But it's going to scream at us because a base weapon is not an identified type here, because this file doesn't have access to whatever is in our base weapon class. This header file here defines what a base weapon is, but this CPP file doesn't know that this header file here exists. We need to tell it that it exists and where it exists. That's what we do with includes. So we can hashtag include just simply base weapon, and now it will include that header file and it will stop screaming at us about our new variable here, because now it knows, oh, wait a second, base weapon, that is that file, that is that header file. I know what that is. I can use the information out of that. So now we can say if that weapon pointer is valid, so if that is not a null pointer, what we want to do is we want to say weapon pointer, and we want to set player pointer, and the player pointer that we're going to give it is going to be just this. Oh, and actually what we did before here, it's still good to have that explained, but we don't actually need that to be a pointer in this case, because we don't need to like change anything about this. So what we can just do is we can say we have a character pointer here, and this will already pass through a pointer. So we don't need that to be a pointer. My apologies for that. I'm going to leave it in though, because knowing that that is a thing is valuable information. Now, it's also screaming at us because this function, I apparently made this in the private section. I made it in the protected section. That makes sense. You do need to put this in the public section if you want to access it from a different class. So even though we have it included in here, that only means that this file now knows of the existence of base weapon. It doesn't mean that I can access things that aren't public about it. I still need these functions to live in the public section in order to actually access them from a different class. Which brings us to the final thing that I want to talk about. I know that this video is a little all over the place talking about a bunch of different little things, but I don't want to make a bunch of 2-minute videos about this. So we have a base weapon we can make in our base magic character now because we have that include. But what if we go into the header file of base magic? If we want to make one of those variables in here, let's say in the protected section, I want to make a base weapon pointer and call that weapon pointer 2, something like that. It doesn't matter because we're not actually going to use this. This is going to also scream at me because even though this CPP file might have the include to base weapon, this header file does not. And as such, it's going to throw an error. So you might think, okay, let's just copy over this include that we have over here and put that all the way up here as well. And that should fix it. And you are partially right. That will fix it. But you shouldn't do that because these header files are generally the thing that are the heaviest to run. And these are the things that are also going to take up the lion's share of the memory of what an object is going to weigh, in a sense. So just slapping on a bunch of different header files onto your header file is generally not a great idea, especially since you don't actually need any of the information that is in the other header file for just declaring this variable. If you just want to let the engine, or rather the compiler, know that, hey, this class exists, you don't need to know what's in it, you don't need to know how to use it, because only the CPP file needs to know how to use it. The header file only needs to know that it exists. You can do what they do up here and simply type the word class in front of it. And that just tells the compiler, hey, this variable type, you might not have any idea what's going on with it within the context of this file. Just know it's a class. That way the compiler knows what it needs to know for this file. It can compile, it won't throw any errors. And then in the actual implementation in the CPP file, that is where you put the include, because there we actually need to get stuff out of that class. We don't need to do that in our .h file. So that's a little bit of everything. We talked mostly about include files. We talked a little bit about casting. We talked a tiny little bit about pointers, just because I need a place to mention it. And this video is just kind of a wishy-washy thing of things you should probably know before going forward. So next time, now that we have all of this stuff out of the way, I think it would be a good idea to start working on the bullets that we're going to be spawning for our twin stick shooter. And maybe, depending on how long it takes us to set all that up, also start spawning them in through our player character. Let's talk about spawning in the bullets for our game here. Because we have our movement, at least in large parts, done. But we want to be able to spawn in our bullets. And for that we need an actor to be able to spawn. So let's go into our C++ classes here, because we have in our public classes a base bullet. So first and foremost, let's make a blueprint class based on that, and we'll call that BP simple bullets. This way we can actually easily spawn in bullets and tweak all of their values and so on and so forth. So let's go into the C++ class for that, because we'll be able to see there's nothing in this blueprint class, and that is because this C++ class is entirely empty. It has a begin play, it has a tick, which both of those are empty. It has a constructor, which doesn't really have anything in it either. So real quick, we're going to go through this. This is all stuff we've done before. We're going to be adding a static mesh component, and we're going to be adding a sphere component. The static mesh is for the mesh of the bullets. You could also use a Niagara component if you want to make your bullet a particle system rather than a mesh. Actually, I think we're going to do that because it's all magic, right? We're going to be doing magic, so using a particle system makes a little bit more sense to me. And then a sphere component, which is going to handle the collision. So in our protected section here, let's add a Niagara component, and capitalization is important, pointer, and we'll call that bullet FX, which will be the effects that the bullet uses for display. And as we discussed before, we don't have the include for the Niagara component here. So we'll just have to tell the compiler that this is a class. And also do make sure, I personally always like to just copy the names from the documentation, which I have open on the other screen over here, just to make sure I didn't make any typos. And then we also want a USphere component, which is probably going to result in a similar error in a moment here. And that will be our collision sphere. And then our bullet effects will be able to create default subobject of type UNiagara component with the name effects, something like that. Doesn't really matter what name we give it. And then we'll use our sphere collision. I called collision sphere, not sphere collision. That makes a lot of sense. And we'll do much of the same thing. That will create a default subobject called the collision sphere. And for that one, we're actually going to also use our collision sphere here. And we're going to set up attachment. And you will note that we actually don't get any suggestions here for what we can do with this class type, and that is because we are missing the include. Sometimes you won't get errors if you don't use includes, but you do miss out on all the IntelliSense, so still nice to just add them in. And now we can set up attachment, and we can attach it to our bullet fx, just like that. That way it will be parented to our bullet. And it doesn't really understand what a Niagara component is either, so we'll have to include that one as well. That way it understands that the Niagara component is also a scene component. And as a matter of fact, let's set root component to the bullet fx. Might as well. And for now, that's all that we're going to do for the bullets. So let's live code. And now in our simple bullet, we have a root component, which is our fx, and we have a collision sphere. And neither of those are editable because I didn't make them into editable UPROPERTIES. UPROPERTY edit defaults only for both of them, and let's try again. And now I can actually set a system here, and I don't have any particle systems at the moment. So for the time being, I'm just going to make one off screen real quick, a very simple one that's just a bunch of circles spawning in. But at least now we can use this particle system here, which can we scale that up? I think we can. Which also scales up the collision sphere. So let's decrease the size of that again, so it's about the size of our bullet, and that doesn't look great, but it's better than nothing. Anyway, let's get back to our code, because that's what we're here for at the end of the day. And with our code, I think we're going to open up our base magic character, because our enemy character and our player character, as you might recall, are both children of this magic character, and the magic character is going to have the function for shooting, which will get driven separately through the enemy and the player, but they both have access to it, because we're going to be pushing that in the protected section in here. So we'll just make a we can just make a void function called shoot bullet, and that will work more or less fine. What I'm going to do though is I'm going to, instead of making this a void, I'm going to make this an actor return type. If you're that new to programming to the point where you don't know what that void we've been using means this entire time, you're about to find out. I'm going to go over it real quickly because this is a useful thing to be able to do. So we'll create a definition, and you'll see we get a return here. And that means that when we use this function in another place in our code, that line of code will act as whatever we put into the return here. So for a simpler example, I'm going to just make a very simple example. I can make a float function called add to numbers, and that takes in a float A and a float B. And that also asks us to return something. And what we'll return is A plus B. And now if I, for instance, in begin play, use that add to numbers function, that will be treated as just a float variable that we can put into somewhere. But let's say I just want to make a float value, can be equal to add to numbers, and then we can put the two parameters in here, so 5 and 19, for instance. Now this line of code will just effectively be equal to saying 24, because what it does is it sees, hey, we have a function here, it's going to run that function and see, okay, we have A and B, A is 5, B is 19, add that together, throw that back into here, and just put a 24. That's what return types do. So with an actor return type, we can make a function that whenever we spawn in a bullet, we can have a reference to that bullet. And I just realized I made a mistake, because this should be returning a actor pointer and not just an actor. You don't necessarily have to do something with that return type though. You can just use a function for its functionality and not use its return. But a function with a return type always needs to have a return at the end of the function. And what we're going to do here is we're going to make a actor pointer, spawned actor, and that will be equal to a function that also has a return type a actor, and that is spawn actor. And in order to spawn an actor, you first need to use the getWorld function here, which will get you a pointer to the world, and the world will be the thing that's capable of spawning in actors. So we can say spawn actor here, and there you want to pass in these pointy brackets the type of actor that you will be spawning. You can also leave that out and specify that within just the normal parameters. If you want a spawn actor function that can spawn different types of actors for whatever reason, you can do that. It's a little bit more bothersome, so the way we're going to do it is we're going to just put it in here, and we're going to spawn a base bullet, for which we will need to include the base bullet, because we don't have an include to that yet. So let's include base bullets. And then as the parameters, we need something called the actor spawn parameters, which is a variable type as well. So let's make those as well. That's a type called f actor spawn parameters, and we'll call that just spawn params. And in spawn params, we have a bunch of different things, like the instigator, meaning what actor spawned this new actor in, and that's going to be just this. That's relevant for things like scorekeeping, right? Because if I spawn in a bullet and that bullet then kills another player or some enemy, especially in multiplayer games, you want to know who that bullet came from that did the killing. So you want to keep track of this kind of thing. And there is a bunch more of these that can be useful, like the override level. If you want to spawn this actor in a specific streaming level, well, that can be very, very relevant, because by default, these will just spawn in the persistent level. So if you want the actor that gets spawned in to be in the same streaming level that you yourself or the actor that spawns it in is in, you will need to use this override level. Something that I personally, with my game, kind of forgot to do for the longest time, and that becomes an issue. And then the spawn collision handling override, which is just telling, hey, if I try to spawn this thing and it ends up overlapping with any existing collision, how should I handle that? Those kind of things you can set up in the spawn parameters. For now, we're only going to set up the instigator. So let's put in our spawn params here. And then the parameters before that, there's a couple different versions of this function that you can use. The one we're going to be using is this one over here. So first you pass in the location that you're going to spawn in, then the rotation, and then the spawn parameters. So for the location, what we're going to do is we're going to add a specific component for where the bullet should get spawned from. So let's add a UPROPERTY here for edits anywhere. Edit defaults only, I think, would be better. So let's edit defaults only. And that will be a UScene component, which is more or less just transform data. It's just as easy as that. A scene component is a component that has a transform and nothing more. All the other components that we're using here, like the camera components and the spring arm components and the child actor components, all are children of the scene components. But if you just need to have a transform somewhere for a purpose like we're using it right here, just making a scene component just gets you a component just refers to a point in space and really doesn't do anything else. And we'll call that spawn location. As easy as that. And then going back up here into the constructor, at the very bottom here of the constructor, we will now create default sub object uScene component, and we'll call that bullet spawn point. Now that we have that, we can just get that spawn location and going back to our shoot bullet function, and then we can find the get component location, which returns the location of the component in world space. That's very important. There's also one that gets you the local location of it. You don't want to use that. You want to get the position in world space. So we get that. And for the rotation, you can do a couple of things. You can say F rotator double colon and just 0 rotator. That will work as a, if you're familiar with Unity, this is just quaternion.identity. If you're not familiar with Unity, this is just something that says, hey, rotation's simply just 0. It's just, this is a way to give a rotation, because you do need to give a rotation without actually needing to input anything in the value. What we're going to do is we're going to match the rotation for the thing that we're spawning with the rotation of our actual character, and that is simple as get actor rotation. And then we have all of our spawn parameters done, I do believe. What you can do if you have a function with a lot of parameters in it, by the way, a nice way of dealing with that is just putting the parameters under each other like this. Empty space in code like this, just like enters, extra spaces, gets ignored by the compiler anyway. So it's fine. Don't forget to add the semicolon though. So now we have an actor pointer here, which is going to get set to point to whatever actor we just spawned in. And we need to return an actor pointer, so we can just return that actor pointer without the parentheses here. It seems like we might have already had a shoot function, which I've entirely ignored up until now, but that's fine. That's entirely fine. Let's just remove that, because the one we just made is the one we're going to be using. Well, there's one big issue with this still, and that is it's always going to spawn in this C++ class, and that's not really what we want. What we want is to use this C++ class, a base bullet, to make blueprint classes that we can have varying damaging amounts or whatever on different particle systems and spawn in those blueprint classes. Luckily, that's actually quite easy to do. So let's get back into the header file here and make a T subclass off, and then these two little pointy brackets, because we're going to be using a template. Well, it's not really a template function, it's more of a template variable in this case, I suppose. And there we put in whatever C++ class we want to choose a blueprint class from. Because what this is going to do in Engine is, when we want to give this a value, we can pick from a drop-down list of all the blueprint children from a certain C++ class. So if we put in a base bullet here, and then call it bullet to spawn, and subclass is not with a capital C. I always make that mistake. I feel like it should be. And we make that a UPROPERTY that we can add it anywhere. You really should probably put this at a default only. So let's just do that actually. Now we can put that in as a parameter in this function as well. It's going to be the first parameter, and now it will spawn in whatever blueprint actor is getting set into this variable. So let's recap what we've just done. We've made this function here, which will return an actor, and that will be the actor that we spawn in. We made the spawn parameters to make sure that the instigator is set to the magic character that actually spawns in the bullet. Then we make a variable for an actor pointer that we're eventually going to return here, which will be the actor that we spawn in. The spawn actor takes in a template here, and that is just telling us what type of actor is about to be spawned in. Then for the parameters, we put in the actual class that we're going to be spawning in, which In most cases, that's going to be a blueprint class because you want to be able to tweak values very easily in Engine. So even if you don't have a bunch of variety of bullets, it's very nice to have just got a blueprint class where you can just say, okay, now this is worth 5 damage without needing to recompile everything. Then we put in the location, which is going to be set from a scene component that we just added. Then it will copy the actor's rotation and use those spawn parameters to spawn everything in. That's how spawn actor works. Now let's map that to a button, because we still don't have a button. Which of course we will do on the player controller that we made last time. So we had this whole input system that we have here, and that was just going to add a new bind action. It's nice to add some comments here to say that this is movement bindings, and then we'll add another comment somewhere here, which will be shooting bindings. And I'm going to skip over a lot of this because this is literally what we did in the last video. So I'm just going to copy over this and change the name to fire input. Then I'm going to make a void fire bullet function, which takes in a input action, because we're going to be using that eventually. At the moment, we're just going to, whenever we press a button, it'll spawn in an actor. I will change that to as long as we have a certain key pressed in, it will shoot in a certain direction in a future video. That's a little beyond what we're doing right here today. This video is long enough as is, so I'm going to speed through this a bit more. So now that we have that, we can copy over this entire setup where we have the enhanced input component, bind action. We'll use the fire input. The event will be, I think triggered will do just fine. And then it will run the fire bullet function when that input is triggered. And in fire bullet, what we're going to do is we're going to, let's see, do we already have the magic character included? No, so we'll hashtag include the base magic character. So let's also make a variable for that. So class a base magic character, which will be our player character. At begin play, we're going to give that a value. So that will be our player character will be equal to a cast to a base magic character. And for the parameter there, we'll get the pawn. So what we'll do is we'll get the pawn. We'll check, hey, is this pawn a base magic character or not? If it is, we'll put that in the player character variable here, which apparently I misspelled something about. Oh, we need that to be a pointer. That makes sense. Again, as I mentioned in my video about pointers, especially if you're rushing, like I'm right now, you might forget this sometimes, but the engine will scream at you when you do it wrong, and you'll just realize, oh, wait a second, that needs to be a pointer. Now that we have that player character variable here, we're going to, first, every time we try to shoot, we're going to check if this is a valid variable or not, otherwise the engine will crash, which you don't want. And if it is valid, we will shoot the bullets, which needs to be in the public section of the header file. Because right now, as we can see, it was in the protected section. We're going to move that to the public section so other classes can use it, like the player controller. And now all the errors are gone. So, real quick recap again. We made a new input action here, and whenever we press that button, which will set up an engine in a second here, we will run this function, fire bullet, which will just use our player character reference that we just made and use the shoot bullet that we've just programmed in, which just will spawn in a bullet. The bullet isn't even going to be moving or anything. It will just spawn in a bullet actor, and that is all that it will do at the moment. But I do believe that is all the C++ code that we're going to be doing for the time being. So let's live code. There is a bunch of stuff that's going wrong. And the issue, I think, is the fact that I didn't forward declare this. So the compiler has no idea what base bullet is, because again, this header file doesn't have an include to it, so we need to forward declare it. And that fixed just about everything. So let's go back to our simple bullet here. That is fine. And then in our player controller, which we have somewhere, surely, we have the new fire input. So let's copy over the input action for movement and call that fire. We can drag that into there. We also want to open up our input mappings context thing and make a new mapping for the input action for firing. And there we're going to, for the time being, just use the up arrow. Again, eventually we will add in context for shooting to the right, shooting to the left, shooting to the bottom, and whatever. That's going to take a little bit more work, and that's going to be probably its own separate video. For now, up is just going to be shooting. Finally, in our player, we can define our bullet to spawn. And you see, as I mentioned, we have our bullet to spawn. And when we drop this down, we get the base bullet, which is the C++ class, but we also get all of the blueprint classes that are children of that we can select here from a drop-down menu, which is, again, fantastic. I love how that works. So now that we'll spawn in at our spawn location, which is a scene component that we have here, and we will just spawn that someplace in front of our character, somewhere like there. And now, if all's gone well, we can press the up button and we can see it spawned in a whole bunch of these bullets, except it spawned them in at a weird position, maybe. It all spawned them in right there. That's because the spawn location was never attached to anything. So let's real quick go back here. These are things that do happen. So the spawn location, we can set up attachments. Let's do the mesh. It doesn't really matter what you attach it to, that just makes the most sense to me. So now when we go back here, we'll see that, let's recompile that. Or sometimes you just entirely need to restart your project because it does weird stuff. Now it is attached to the mesh, so we should be able to spawn them in front. Let's see. We do. We spawn them in a weird location though. Why would that be? Oh, that is because that is actually where I put the point. So it spawns exactly where we think it should spawn. Now, at the moment, it spawns them in as long as I hold it down, which obviously, yeah, that's not really what we want to do. But at least we're spawning in these actors when we press the right button. So we could change this from triggered, which will continuously keep spawning these things in, to, I think it's called started, which will only spawn them in, only trigger that function when we initially press it. But for the eventual gameplay, we're going to want this functionality, which is going to change things around a little bit. So next time, before we actually get into all of the more complicated shooting things around in the direction that we want to shoot them around in, we're going to talk about timers and have a timer that whenever a bullet is fired is going to disable our ability to fire bullets, start a timer, and once that timer runs out, it will enable us to shoot another bullet. That way we can hold down the key and it will only shoot a bullet once every third of a second, or once every 2 seconds, or whatever your fire rate will end up being. And I guess we'll also actually add in the movement for the bullets, because right now they just spawn in and hang out. That's all for next time though. Right now, this has been quite enough, I think. So we can shoot our bullets, except the bullets don't move and they spawn in literally every frame as long as we hold down the shooting button, which both of those aren't exactly ideal. So let's fix both of those real quick in today's video. The majority here is going to be about setting a timer to make sure it only lets you shoot every 0.2 seconds or so. But before we do that, let's actually go real quick into our bullet class and add another component to that. That's going to be a UPROPERTY, and that will be a class named UProjectile Movement Component, which is a very big name, so I'm just copying it over from the documentation. And let's call that projectile movement. And of course that needs to be a pointer, something that's so easy to just forget. And we can add that in here. So we'll just, as we're used to, create default sub-object of the type, which again, I'm just going to copy paste that because that word is way too long with way too many chances to make a typo. We also need to use its include. And then we can also set up some of the defaults in here as well. We can always change this in engine if we want to, but we want to, for instance, disable the gravity scale. So our projectile gravity scale will simply be set to 0 so that it doesn't fall through the floor. And in theory, that should be all we need to set, because you can also worry about setting its direction and its speed values through code like here. We're going to worry about that a little bit later. But let's make a UPROPERTY here real quick for the speed and set that to public, because we might need to use that from another class. Now, let's get into the whole timer business, because as it is in our player controller over here, we have a input action that is bound, set to event triggered, to fire bullets whenever we do this input action, which is set to a certain key. The issue is that it now spawns in a bullet every frame, as we could see at the start of the video, and we don't really want that. We want to have a way to see, have we fired in the last X amount of time? And if we have, we don't want to shoot a bullet. So let's go into our player controller's header here, and we can, in the protected, or hell, even in the private section if we wanted to, simply make a bool called can fire. And we want to make sure by default that is set to true. So it can always fire unless we tell it, hey, stop firing. If we go back to our shoot bullets here, our fire bullets, we first check if the player character is a valid pointer, if it's not a null pointer. In that same if statement, we're going to put two ampersand signs to check for two different conditions. The other one is can fire, the bool we just made. So this has to be true in order for the shoot bullets function to be able to run. Now, after we run that shoot bullet function, we set can fire to being false. So now after we fire once, we'll never be able to fire again. And that is because when this is set to false, this if statement no longer fully holds true, and this code will never run again. So we need to put something in place to set that bool back to being true after a certain amount of time. And that is where timers come in. So timers, we need to make a separate function that we can tell the engine to run after a certain amount of time. You can't just say wait 5 seconds and then do some more code. You can only say, hey, in a certain amount of time, run this different function. It's not like what you have in Python, where you can say, I think it's called sleep, just sleep X amount of seconds and then move on with the rest of the code. You can't really do that, which is too bad, because that would be fantastic. So let's also create a float here. And realistically, this would be a float that you want to have on the weapon, not on the player controller. But for now, let's keep it simple and say time between fires. And we will make that a UPROPERTY that we can add anywhere, so that we can easily try and play around with how much time that takes. By default, let's set that to 0.2 F. The F, so the code knows that we're talking about a float here. Making a timer. Well, we do have a little macro. If you have the plugin that I taught you to download at the start of the series, which is UTimerSet, and that just puts in the code that you would otherwise have to manually write. So what you need to do is you need to get world, just like we needed to do for spawning in actor. And then from that, you can get the time manager, which is an object that's all about the time that goes on in your world. That has a function called setTimer that takes in a timer handle, which we'll need to make in a moment. A object, which is just going to be this. That is the object that you are going to run a function on in a certain amount of time. The address of that function, the delay time. So for us, that's going to be that variable that we just made, and whether or not this should loop. So maybe you want a timer that does something every 5 seconds from the moment it's first fired. In that case, this would be true. By default, this is false, so you can just leave it off, I believe, and it will just be false by default. So let's make our way back. We need a class here. Well, that's the class that we're on right now, so that's easy. And we need a function. Well, let's make that function and call that void reset can fire. And this function is really going to be easy because it's literally just setting can fire to being true again. That way, whenever we get back to this again, this if statement is now completed and we can shoot the bullet again, set it to false and run this timer again, after which we set it to true and the whole thing can run over and over and over again. So we'll put in reset can fire for the function here. This is just this. Pretty much always going to be just this, the object that you need to put in, because you're running a function on this object. Then we need to put in a timer handle, and that is a variable type called fTimer handle, and we'll just call that timer handle, because I think that is by default the name that macro uses. A timer handle is kind of like a manager that just keeps track of, hey, am I running a timer at the moment? Because it could very well be the case that you make this as a variable on your header file as a member, at which point these timer handles can only run one timer at a time. And sometimes maybe when a timer is already running, you don't want to allow it to run the timer again, to restart the timer until it's finished running. Or maybe you do want to reset a timer, or so on and so forth. In that case, you would declare that in your header file, so you always have access to it and it always survives. This way you can just set it and forget it. You just create the timer handle, pass it in here, and after that it gets destroyed anyway. And honestly, most of the time you do it this way. So the whole timer handle situation, not too relevant, just you do need to do it, is the thing. Well, that's all fine and dandy, but what if instead we want to do something on a timer for which we need a parameter? Because this can only call normal functions without any parameters in them. And that's why we have setFire directly set to true. But that's a little bit messy, because what if on this same class we also have a function for setFire that we do based on a parameter? Because it's very likely that a class like this would have something like that. So let's just change this function to setCanFire, which takes in a bool parameter for the value. And then this will also take in the bool parameter, of course, and we'll change the name here. And this will start screaming at us because this function no longer exists. But that's okay, because we actually are going to get rid of this in a second. Because you can set timers for functions with parameters. It just takes one little extra line of code. And that is, we're going to make an fTimer delegate instead. And we'll call that delegate. And that we will set equal to fTimer delegate, double colon. We're going to be using a static function for this. Create uObject. And in this, we're going to take these two parameters and put them into this delegate instead. And of course, we need to use the proper name for the function here. And this will now allow us to put in the parameters for this function into this delegate. So this function takes one bool parameter. In this case, that's going to be a value of true. And now suddenly we have an object here that we can pass in instead, that will run this with the value that we just put in. If you're using this one for whatever reason, you do need to specifically say that looping is true or false. You can leave it off in the other scenario. In this scenario, you can't. That seems just like an oversight to me, but do be aware of that. And now we can use this function elsewhere. And we can even, if we wanted to, make another system where it gets set to false after 0.1 seconds and then back to true after 0.2 seconds in total. Because we now have a much more flexible function that we can call on a timer with a parameter. So really, that is all there is to it as far as these timers go. So let's compile the whole thing here. And now we should see that we're only spawning these things every so often, and not every frame anymore. We're still spawning them relatively often, and they're still not flying anywhere. That we will fix in a moment. But we do have a projectile movement component on this thing. So we'll just set the initial speed. I forgot to do that to something like, I don't know, 100, and then the max speed to, let's also set that to 100 right now. You probably want to set this through some sort of code. But once we've done that, you will see these things actually start moving, and 100 is way too low. So let's set this to 1000 instead. And that is much better. So now we've got a character that can move around, and I can just hold down this button over here and it will shoot a bullet every 0.2 seconds. And the wonderful thing about this as well is before we were spawning every frame, which is fine, kind of, maybe, not really. But since we're using a timer that just works on real world seconds, this is now also immediately frame rate independent. Even if my frame rate absolutely tanks, to a reasonable degree anyway, I will still be shooting every 0.2 seconds. So that's quite nice. Now, real quick, because we're doing this whole bullet thing anyway, I'm going to add in the other 3 directions as well here. So that's up, down, left, and right. And we're going to be copying the modifiers from the WASD because those are the same directions. And you can just copy modifiers and then paste them on here. So I'm going to do that, and we're going to skip over all that because that is not too interesting. You can also do it by shift right mouse for copying, and then the A key will be the left, and shift left click to paste. And real quick, back in our code, what we want to do is we want to set our player character to face in the direction that matches our inputs here, and only then fire. So we're going to split this up into 2 separate if statements. Real quick, we're going to check can fire only after we have already set the rotation. We want to set the rotation always, but we don't always want to fire. So we will use the player character, set actor rotation. And to get that rotation, we're going to make a F vector for direction, which I misspelled, but that doesn't matter right now. And that will be equal to F vector with a value of our input action value, dot get. And we will be getting a F vector 2D and adding a 0 onto that. Then we can use that direction. And you can actually very easily get a rotator out of a F vector by just putting in your F vector. Dot rotation, and that should just simply spit out a F rotator that you can use to set your actor rotation. So this will be relatively clunky, I will admit, because this needs a lot more polish, but this should allow us to add some rudimentary aiming, which doesn't seem to be working for our mesh for whatever reason, but at least we can actually like aim where we shoot, which that's a start. I'm not entirely sure why the mesh is not getting set to rotate though. Alright, I'm going to be real with you. I don't know why the difference that I programmed in worked, but it's something that we needed to do long term anyway. But now we actually do rotate in the direction that we were shooting in, and we can still shoot in any direction while walking in any direction. Now, I'll give you a real quick rundown on what I did. Is I took the code for rotating out of the fire bullet. Instead, I'm storing that in a F rotator now. So I made an F rotator variable on the header file, and I'm just setting it to that. And then I created a tick function, which is just something that every actor can have, runs every frame. You're probably familiar with it. And I'm just setting the actor rotation in that every tick. And for some reason that does work. We needed to do this anyway, long term, because what we want to end up doing is whenever we are shooting, we want to orientate ourselves in the direction that we're shooting in. But whenever we're not shooting, we want to look at the direction that we are walking in. So we need to make something for that anyway that runs in the tick function, which we might as well do that right now. So what we'll do is I'll make another F rotator here, and that will be our movement rotation. And in our movement, I will simply set our movement rotation variable to be equal to our input vector dot rotation. And now we just need a bool to check whether or not we are shooting. So the way we're gonna do that is gonna be a pretty hacky way. And that is, we're going to just get this bind action, and we're going to copy that over twice. And once we're going to run on started, and then once on cancelled, I believe is the one we want. And we'll simply make 2 functions here. Again, I'm just doing this in a little bit of a hacky way, but it will work. So we'll do a void set shooting true. Ideally, you want these to just run the same function, but I honestly don't care too much at the moment. So we'll make one for true and one for false, and we'll have a bool is shooting, and it's as simple as setting it false in this function, then copying over this function and making the true version of it. It is important to get the capitalization right though, and then adding those to these bindings. So we have the started will be the true, and then when we let go of it, it will be set to false. And then in our tick, it's as simple as if is shooting, we do this, and else we set it to the movement rotation. And that in theory should do the trick, I hope. And now we can walk around and we can shoot, and as long as we're shooting, we will be facing the direction that we're shooting. When we stop shooting, we use the wrong event. So I guess we need to use completed and not cancelled. I always get these events mixed up. They're really poorly named, in my opinion. I'm gonna just go ahead and say that. But now we can walk in any direction, and when we start shooting in a direction, there is one shot that still is fired in the direction that we were walking in. That's a little bit of a bug, but by and large, this is a more or less functioning twin stick shooter now. Of course, at the moment, I don't have a controller to test this out with, but if you have a controller, this should work with 360-degree movement rather than just directional movement. So now that we can walk around and we can shoot all we like, we have the basics of a twin stick shooter, but these bullets are just going to fly through walls, and if we were to make enemies, they're just going to fly through enemies, because we don't really have any programming to tell them what to do when they collide with something. They have a collision that's set to overlapping things, but they aren't being told what to do when that overlap actually happens. So let's take a look at that. On a normal blueprint, you might be used to having a begin overlap event. And that is very nice, and we're going to do something similar to that in C++. So what we're going to do here is I'm going to open up the base bullet class, because that's the thing that's going to be colliding or overlapping with all things. And I also have a other class open here because the overlap function that we're going to use does have quite a few parameters, and I don't want to mess them up. So I'm just going to copy over from my own game where I have a class that also has a begin overlap function. It's very important that your overlap function has these exact parameters, because we're going to bind it to a delegate, which we'll explain more detail a little later maybe. And when binding to certain delegates, you do need to make sure that the things you bind to it match it in terms of these parameters. Even if you don't plan on using all of them, you do need to have all of them. So what are all of these? Well, the primitive component is the overlapped component. So that is the component on this actor that's getting overlapped. Other actor is pretty self-explanatory. That's a pointer to the actor that you are overlapping with. The other component is the components on the other actor that you are overlapping with. The other body index I have never used, so frankly, I'm not entirely sure. And then we have a bool and a hit result for sweeping, and that has to do with sweeping is more or less checking one frame ahead whether or not something is going to collide, instead of checking whether or not it is colliding. So if this overlap happens as a result from a sweep and not from an actual direct collision, this will be true, and the hit results from that sweep will be stored in this variable or this parameter here. Now that we have that, let's make the definition for it, and we can start coding that in a moment. But this won't automatically do anything, because we're never running this, and it's not like just calling it begin overlap is going to run it when you overlap with something. It's not that smart. We're going to need to bind this to a delegate, as I alluded to before, and we'll do that at begin play. So how do we do that? Well, we already have a collision sphere, a sphere component here that is set to overlapping. So if we just get that collision sphere and we say on component begin overlap, we can add dynamic, and there we pass in a object, which is going to be this, and then we pass in the address of a function that matches this signature which is the overlap component, other actor, other components, and so on and so forth, the thing we just went over. And if you pass that in, now whenever something overlaps with this component, this function is going to run, and all of these parameters are going to get filled in with the relevant information. And that is, in a nutshell, also how delegates work. We'll get a bit more into delegates and making your own delegates and stuff like that in a future video pretty soon, because it's very useful stuff to actually use. Today we're not going to play around with delegates too much. I do want to show you something that is almost equally as useful and is a little easier to understand and wrap your head around as a secondary objective in this video. Oh, and it is important to also mark whatever function you are binding there as a U function. Because when we overlap, what are we going to do? Well, first and foremost, we're going to destroy this. We're just going to destroy the thing itself. But we also want to do a number of different other things. And that is, we want to spawn a new particle system. And we want to, if it is a character that we are colliding with, we want to actually damage that character. Now the damaging we're going to leave for the next time, because I want to really dive a little bit more into it due to the fact that Unreal has a built-in damage system where you can send a deal damage to an actor, and then that actor will run its receive damage function, and then you put all that information in there as to how that damage should be calculated, rather than calculating that all over here and just subtracting a number on a different actor. It's a very good system. It's a little much to get into today as well. But maybe you want to have some bullets that do special stuff, right? Maybe we want to have some bullets that when they impact, they spawn 3 new bullets that fly off in random directions. Maybe we want to have a bullet that when it hits, it creates an area of effect damage thing. Whatever we want to make a function that we can put different kinds of things in depending on the kind of bullet that we're using. And that's what we're going to get into right now, because we're going to be talking about virtual override methods. You've seen me talk about this a little bit before and kind of dodge around it because I wanted to explain it in a more proper context, and that's what we're going to be doing here. So in our protected section, we're going to be making a new function here, which we will first mark as a virtual. That will be a void, and we'll say it's called bullet hits. And you do want to spell virtual correctly. So what does virtual mean? Virtual means that this function can be overwritten by child classes of this class. So let's use the tick function as an example, because this is a virtual function, meaning that if I make a child of my base bullet, which maybe again we want to make an area of effect bullet, so we would make a child class of this one, and then I could override whatever is in this tick function. So in this case, the bullet hit function itself on this class is going to be entirely empty. But if I make a child class that does make use of it, I can override the bullet hit, and suddenly it will do whatever I put into that function, because this base bullet says, just run the bullet hit function, and whatever is in it, we're just going to run, and we can actually fill that in on a child by child basis, which is really, really powerful. The override keyword at the end here is just something for you as a programmer to keep track of. Hey, oh yeah, this is an override method. It's not actually needed. It's just something that checks, hey, this function, does that A, even exist on the parent class to begin with? And B, more importantly, is it virtual or not? Because if it's not marked as virtual, you can't override it. So let's make a definition for it, because you do need to do that. And then whenever we overlap with something, we're going to run the bullet hit function, which again, in this class itself is going to be entirely empty, but we can make child classes of this, which will still run this function, but if it's overridden, it will do something different, whatever we put into it. And in a function that is an override function, like we have seen before, you will see that it can start with this super tick in this case. And that is just saying the function that exists with this name and these parameters on the parent class, which there exists a take function on the parent class of base bullet, because that's just actor. Run that first and then run whatever code I put in here. Or you can also run it at the very end if you wanted to. If you don't put this super tick in there, like I don't have that in my own class because I don't have anything in the parent function. But say you do have some functionality in the parent function that you don't want to run in the child version, you simply just don't include the super here, and it won't run whatever is in the parent function. And as an example from my own game here, I'll show you a little bit of code. That's the class that I took the begin overlap from as well. But here I also have a virtual void method called special attack. And you will see that special attack in this class doesn't have anything in it. And that is for the base weapon class. So I just make a class for the base weapon. That's not actually going to get implemented into any blueprints. But then all my other weapons are children of that. So if I go into my sword class here, you can see it's a child of the weapon class. And it has a override for the special attack. And here I actually do have a bunch of code. And this way my character just has a reference to a weapon. And whenever I do the special attack, all the character needs to know is just tell my weapon to do the special attack. And then based on what weapon I am wielding at that given time, it will execute the corresponding code to that specific weapon. Now, let's also make a UPROPERTY edit defaults only for a UNiagara system, which is distinctly different from a UNiagara component that we've used somewhere before here. Here, that's a component, which means that it's going to get built as a default subobject in the constructor and is going to be a component on this actor. This is just a Niagara system pointer, which is going to point to a Niagara system that we can then spawn in as a separate actor through some different code. So this is not going to be a component on this actor at all. This is just something that can hold the type of emitter that we want to spawn in whenever we overlap with something, which will be an entirely different actor, which is important because when we overlap with something, very soon after that, we're going to destroy ourselves. So we spawn in a separate actor to do some particle stuff. And that's going to need to be forward declared, actually. And we'll call that impacts particles. And we will need the include for Niagara system.h in our CPP file. And that's not the only include that we need, because we also need to include the Niagara function library, since we need to have a way to spawn in that system as a separate actor. So that is the include Niagara function library. And now in our begin overlap again, we will say Niagara function library, and then we will spawn system at location. And for that we will need our world context object, which is going to be this as always. Then the Niagara system, which will be our impact particles. Then we need the location, which is just going to be our get actor location, which is going to spawn it in at the exact same place that we are at right now. The rotation by default is set to F rotator 0 rotator. The scale is just going to be 1. Auto destroy is automatically true. Auto activate is automatically true. And that's really all we care about. So we don't even need to put in any of the other parameters, because a lot of these parameters have default values. And when they have default values, we can just skip them altogether, which is great. So right now we have on our begin overlap, we are spawning a system at our location. We run the bullet hit function, which isn't doing anything right now, but it will give us the ability to do things in the future, which is really nice. And then we destroy this object. That's my bad. You don't actually need to put in a thing to destroy in the parameters here, because it would just destroy whatever object this is being run on. So if we had a different object like other actor, if we wanted to destroy the other actor, we would do it like this instead. If you don't put anything into the parameters, it will just destroy itself anyway. So I made a little mistake, but I hope that that's not too confusing. And now in our simple bullet, we have the impact particle variable here. I just made a simple impact particle system. and let's see if it works. And this map might not be the best example here because you do seem to need to have generate overlap events on the target on as well. By and large, that's not that big a deal, but you'll see I just enabled it for this pillar. This pillar they just go straight through, and this pillar they will explode up against. And it does seem like they are looping. Actually, we don't want them to loop. That's an issue with the particle system itself. I've set it set to loop infinitely. It should only loop once. And there we go. We have shooting, and we can interact with things. That's all very, very cool. So that is how you set up basic collision related things in C++. Again, do be aware that in order for that to work, you do need to have set generate overlap events on whatever you are going to be overlapping with, it seems like, which is highly annoying, but it does make sense. Like this character has it set to on by default, so if we put in another one of these characters over here, we can shoot this and that should do the trick. And of course it doesn't have any AI because we didn't program any AI, but you can see this way we can shoot at the enemies. And you probably want to also, the walls of like your dungeon or whatever you're making, probably want to also set them to have overlap events enabled, because that way these bullets won't go through the wall. And the reason that is relevant is because these bullets, if I press F8, I will be able to highlight one of the bullets that just flew off into nothingness, is all the way over there, and that's not going to despawn. And if you play for like half an hour, there's going to be thousands of these things just flying out into nothingness and taking up a whole bunch of your memory. So you don't want that. You do want them to kill themselves after a certain time. So if you just make sure that all the walls will generate overlap events, it will just kill itself when it runs into a wall. It's also not a bad idea to just put in a timer in the bullet itself to just say, after 30 seconds, just like despawn yourself. Just kill yourself after 30 seconds. You're not going to be relevant anymore anyway. A game in which you can shoot an enemy and it doesn't die isn't a particularly exciting game. So today let's talk about setting up an HP value for enemies and ourselves, as a matter of fact, and also dealing with damage to that HP value. It's actually remarkably simple. Unreal has an entire built-in system for damage, because pretty much any game you're going to be making is going to have some sort of damaging or HP value system. So let's dive right into the code. And for that, we're going to go into our base magic character, because both the enemy and the player will need to have this information. We're going to go back into our bullets here, and when we overlap with something, what we're going to do is we spawn that Niagara system, and we run the bullet hit function, which doesn't do anything for the time being. We need to make sure that we have the gameplay statics included here, because apply damage is a gameplay static function. So we'll include that. And as you probably should know by now, that's in Kismet gameplay statics. And from there we can use gameplay statics, and we can say apply damage. There's a couple different ones here actually that I probably should highlight. There's point damage, radial damage, just normal damage, radial damage with fall off. For right now we're just going to go for apply damage, but these are different types of damage causing. So we can say point damage hurts the specified actor with the specified impact. What's more important here is things like radial damage or radial damage with fall off. These are things you can use for AoE attacks. So if you have a grenade, instead of spawning in like a whole collision box when it explodes to calculate who is inside this collision box and all that nonsense, you can just apply radial damage, and you can give in a radius or a radius with a fall off, and the damage will be calculated for everything within that radius. And with, if you use with fall off, it will also the closer you are to it, the more damage it will do. So that's actually very, very useful, very, very handy to have. Today we're just going to use the normal applied damage because that's all that we really need. And that's the first parameter there, is a damage actor, which is going to be the other actor which we are overlapping with. Then we need to put in a float for the base damage. For that, we're just going to make a UPROPERTY float base damage. So every type of bullet we create can have a different amount of damage it can do. Then next we need to put in a controller for who the instigator is. But let's make a separate variable for that up here first, actually, to make it a little bit less messy. So a controller player C for player controller, I guess, will be equal to get instigator. And that will get us the pawn that instigated this thing. But of course we need a controller, so we'll get controller out of that. And you'll easily see, after we make this into a pointer, this line of code now makes sense, and we can simply just use that variable in here instead of having an entire line in there, because that's just very messy. The damage causer will just be this, which is this bullet. And then finally we need to put in the damage type. So let's just make, for shits and giggles, a UPROPERTY for the damage type. Just put it in there in case we want to use it at a later point. So that will be a U damage type. But actually I think we need to make that a T subclass of U damage type. Because the way you make new damage types is making a class that is a child of the damage type class, and that way you can also put code into it, I believe. I haven't really done too much with this myself, but it's fun to just play around with a little bit. So let's call this just damage type. And then when we put that in there, I think this should now be a valid function. And now this will use the gameplay statics apply damage to get the other actor and apply a base damage amount, which is a variable that we made, amount of damage to that actor, and it will pass through the controller that we have found as the instigator, the damaging actor, so the bullet that actually dealt the damage, as this very object with whatever damage type this bullet has on it. So with that, and then on our base magic character, we will just copying this from the Unreal documentation, use the take damage function here, and that will be an override function because we are overriding a pre-existing function that exists on any actor, really. And that takes in a float for the damage amount, it takes in a damage event, it takes in a controller for the instigator, and a actor for the damage causer. And we'll just implement this right here. This returns a float, which will honestly not be that important, I think, but we'll just return our damage amount here. And in here we can just put in any code that we want. And what we're going to be doing with taking damage is we make an HP value, which I already did for you because it's really that easy. A UPROPERTY just called HP, it's going to be a float, and it will be HP minus equals the damage amount. It's as easy as that. And then in there we'll also include if the HP is less than or equal to 0, we will also destroy that actor. And now when we apply damage, we will just make this run its take damage function. Now that we have this take damage set up, we can compile this whole thing, which I've moved that to my other screen because it kept overlaying with things and it just looked very ugly, honestly. We can see if we shoot this twice, he dies because our damage, I think we're doing 30 damage or something. I think I hard-coded that in just for testing purposes. Probably shouldn't do that. Yeah, that definitely should just be our variable. But our damaging works. So we damage things, and when they have less than 0 HP, they just get destroyed. And you can add whatever code you want to that. You have a reference to the instigator, which is your player controller. So if your player controller has something like a score value on it, you can just cast that controller to your player controller and add your score value to that player controller. It's really as easy as that. And now you will note, since we're doing 20 damage again, it will take 3 hits for this dude to die. Apparently more than 3 hits. I don't know why that didn't hit him. It probably actually hit his weapon, and that didn't count because we're hitting a different actor. That's a thing that you should be aware of. If you have multiple different actors very close together, and the child actor component is a different actor, it is a component, but it's also a different actor, it can very much be the case that like your weapon will block an attack and that will prevent damage from being dealt, which can be annoying. Or it can be a game feature, right? It's not a bug, it's a feature. And that's the basics of the Unreal damage system. Again, you could just make something that whenever the bullet collides with it, it casts to our base magic character and just directly subtracts things from the HP, or runs a function on that subtracts from the HP. But Unreal has a really robust built-in damage system, as you've been able to see. It's a little bit more bothersome to use than that way, but it's also a lot more flexible. And in most types of games that you're going to be making, you don't want to rebuild this entire stuff yourself, right? That's the reason we're using Unreal for the most part, is it has a lot of pre-built, very robust, very powerful tools, so do learn to use them. It is also worth noting, by the way, that if you have your health or whatever, you want to have that code on a component rather than on the actor itself, there is a good way of doing that with this on-take any damage delegate as well. In this video, we've only done it directly on the actor, and you can just run the take damage function, and that is the easiest way to do it. If for whatever reason, like me, you have a component here in my own game, which holds all of the values for HP and that kind of stuff, what I do here, real quick, is on begin play, on that stat component, I get the owner, which is just the actor that this component is on, and then on take any damage, I bind with add dynamic again, this object, so this component, and then the take damage function for that, and that has a slightly different signature if we're using this method. So what we're doing there is we want to have the damaged actor, a float for the damage, the U damage type, which has to be a const, then the controller, which is the instigator, and then the damage dealer as a damage causer. So it's slightly different. And this doesn't have to be called take damage either. This can be called whatever, because we're not overriding any functions. We're not adding any functionality to parent classes or anything. This is just a function that we bind to on take any damage. So that is how I personally do it in my game. It's a little bit more of a roundabout way of doing it, but it is also a way that you can do it. We have quite a lot already made here. We can move around, we can shoot, but we don't have our walking animation yet. And that is because that's going to be a little bit more complex, because that walking animation is going to always be a forward walking animation. But when we're shooting, the walking animation is going to be influenced by the direction that we're shooting in and that we're walking in. And all that stuff together makes for a little bit more complex calculations, which we're going to do in C++. But we want to do all of those calculations in C++, and simply when we're using those in Blueprint, we're going to use them in an animation blueprint. We want those just accessible through one simple node, so that we don't have to redo all those calculations every single time when we want to use them in our animation blueprints. So I have made an animation blueprint here real quick, where I just get the base player character, get its controller, make variables from that, get a velocity variable, which I don't think I actually need. And I also set up a simple blend space, which I will show you right here, which will blend between walking forward, walking backwards, strafing left and strafing right, or the other way around. And that just has a forward speed input and a side speed input that we can use. So if we go into our animation graph, we'll see I also set that up here. We have that blend space with two variables going into it. We're going to need to set these two variables. Now, in the event graph, what we want is we want to make a new custom event real quick, and that will just be our set walk animation, something along those lines. And at the very end here, that's what we're going to call. And this entirely depends on whether or not we're shooting, what we're going to be doing with this. So we want to set this is shooting variable that I've already pre-made as well, to be the is shooting from our base player character. So let's see, is shooting, that's not available to us because I haven't made it a UPROPERTY yet. And that's where we're going to get into some interesting stuff in a moment. So let's go to our base magic character and look into or rather into the player controller, because that is where we have the is shooting variable. Maybe that should be on the character itself. We'll see whether or not we want to end up changing that or not. But we're going to make this a U property, which will be blueprint read only. We only ever want to read this. Let's compile that. And that makes a lot of sense as well, why we couldn't get it out of the character, because we need to get is shooting out of the controller. So now that we have that variable in our, I'll zoom in a little bit actually, in here, we're going to use that is shooting for a simple branch. If we are shooting, we're going to do some math, which again, we're going to do in C++ in a moment. If we are not shooting, what we want to do is we want to set our side-to-side movement to 0. And our forward movement is going to be our velocity. And we're going to get the length out of that. And for now, you will see that that means that as long as we are just walking around, we are always walking forward, and that works perfectly fine. The moment we start shooting, things break apart a little bit because we haven't programmed in what we're going to do there yet. So, of course, what we want to do is we're going to want to set the blend for the side and for the forward in that case too. But how are we going to get that information? We're going to get that through a blueprint pure node. And if you're thinking about blueprint pure node, what does that mean? If you are used to using things like get game mode, this is a blueprint pure node. It's a blueprint node that doesn't have an execution pin and is just a function that returns a value. Simple as that. You can make those yourself in C++ as well. So let's go back into Visual Studio Code here and make a function for that. So we want to make a function that returns 2 floats. And you can't really do that. Well, you can do that in a few ways. You can pass in a pointer to a float variable and change that in the function. But that's not really what we want to do with a blueprint pure node, because that then requires execution stuff. Instead, what we're going to do is we're just going to make something that returns an f vector, and we'll call that calculate movement blending. And that's going to be a U function, and the type will be blueprint pure. And let's make an implementation for that real quick and compile, just so that I can show you how it works in Engine. So now that we have that, we can use our controller variable that we've made. Remember, we made that right here after casting to it. And now we can simply get the calculate movement blending, which will simply return a vector here that we can split. And we're going to, when we make the function in a moment, we're just going to set the X to being the side to side here and the Y to being the forward blending. And that way we can get these 2 values out of one blueprint pure node. So let's just plug those in already. So that's all set up. Now let's go back into C++ and start coding this thing. Importantly, in a previous video, we made a F rotator for the shooting rotation and an F rotator for the movement rotation, which gets set whenever we input anything to do with shooting or movement. So we're going to be using both of those rotators here today. And we're going to be making F vector for the movement, which will be equal to our movement rotation dot vector. That way it just gets converted into a normalized vector. I believe it's normalized anyway. And then we'll do the same thing with our shooting rotation as well. This way we can actually do vector math with it. The rotators themselves are a little bit weird. What we want to end up doing is we want to get a float here, and that float is going to be our dot product of those 2 vectors. If you don't know what a dot product is, the dot product of 2 vectors is a float that just more or less tells you how much of a difference there is between the 2 vector directions. And we can get that from the f vector static function called dot product, which takes in our 2 vectors here. So that will be our movement vector and our shooting vector. And now we have a float that has that dot product in it. And actually that dot product is going to be our forward blending component here. So that's, I believe, the X components in the vector that we're going to eventually return. But we also need the side to side, and that needs a little bit more math to it. Just a little bit, not too much. What we want to do with that is we want to get our original shooting vector here, and we want to multiply that by our dot product. And then we want to get our movement vector here and put that in front and subtract the shooting multiplied by the dot product from that. And just for good measure, let's make that into a variable here of its own. So that will be our blend vector. It's not a very good name for it, but we're gonna stick with it for now, because the length of this vector will be our side to side movement. So now we have everything we need. So let's just simply make a vector again here, and let's call that output vector, and that will be equal to a F vector where the X component will be our dot product, the Y component will be the length of our blend vector, so that blend vector dot length, and the Z component will just be 0. And then that is the vector that we will be returning. And it seems like I mixed up the side to side and the forward blending, so I'm just going to switch those back around because it's easier than going back into C++ and changing things there. So in theory now, we can walk around and we can shoot, but we still are stuck in the idle animation. And that actually does make sense, believe it or not, because what we are returning here is a vector of a value that is somewhere in the range of like 110. That's not very much. So what we actually want to do here is we want to return our output vector multiplied by something like 100. That way all of the components get increased to a size where we can actually reasonably work with them. You could also change the blend space around to blend between values of 1 and 1 rather than 100 and 100, which I did. I prefer doing it this way, but it's very much up to yourself. And now you can see we are moving in the direction that we are putting in, and the animation actually matches depending on what direction we are shooting in. No matter what direction we're shooting in and what direction we're moving in, our animations match up to those directions, which is very nice. Now, there's quite a bit of math here with doing the dot product and then multiplying and subtracting and adding and all that kind of stuff, which that might intimidate people a little bit. But really what's happening here isn't all that complicated. And if you just go through it a couple of times, you'll probably start to understand what this is all about. The main thing that I wanted to show off here today isn't all of this math, because math is boring, right? The main thing I wanted to show instead is the blueprint pure U functions, in which we can have one of these nodes that doesn't need to have an execution input and instead just calculate something to return a value for you to use. So if you just have a single variable that you want out of a C++ class, you can just make it a UPROPERTY and blueprint read only or blueprint read write. But if you want to have something that needs to be calculated in a function in C++ and you just want a simple output, just something like what we did here today with calculating this, you can make it a blueprint pure node, and that way it just returns your eventual output value without you having to set up a whole bunch of calculations in blueprint, because that's the whole reason we're using C++, so we don't need to do this basic stuff in blueprint. We pretty much have a playable character now. We can walk around, we can shoot, and this is really what a twin stick shooter is about. And that means that we're starting to edge up against something that might resemble the end of this C++ basic series. There's a lot of things to still talk about, so let's get started on making an enemy here, because we have a player, but what is a game where you shoot things without things to shoot? So let's make things to shoot. And for that, I'm going to admit something to you. We put a lot of code in our player controller here, and for the most part, that worked fine until now, because a lot of the code in this player controller we would have to duplicate in our enemy AI controller, because things like this shoot bullet kind of thing, this code probably should have been on the character itself, because both the player and the enemy are going to need to do this stuff. So let's take our base magic character here, and we have this shoot bullet where it spawns in the bullet, and then, well, the bullet fires itself. And we just call that function here anyway. So what we will instead do is we'll change things around a little bit and prepare things for an AI to be able to use them as well. So what we'll do is, going back into the base magic character here, we're going to instead take in our shooting direction as a parameter here. And we're going to change the can fire variable also over to the character itself rather than the controller and all that stuff. I'm not going to bother you too much with that, but I will show you in the end. So I'm going to zoom out, and I'm just going to quickly migrate all this code over to my base magic character. So first and foremost, let's just cut everything out of this function. And I'm going to just put all that on top of this function here. That's going to make this quite a big function, unnecessarily big, really. We're going to take this player character, shoot bullets, back into our controller. It's just going to always run this function, and then within this function, that's not ideal, but that's the way we're going to do it right now. Within this function, we're going to check whether or not we should be shooting in the first place. You can take out that if statement as well. The direction that we're going to be using here will be a parameter for this function instead. So let's put that in the header file as well. We can cut out this line and also put that back into our controller. And we're going to put that before we actually call the function, because this vector is going to need to be the parameter for that shoot bullet function. And then we're going to need to copy over a couple of variables here. Like the shooting rotation and the can fire, the time between fires. We're going to need to copy over a function, all that kind of stuff. I would like you to do that on your own. I'm not going to walk you through everything, just moving over code. You can just move over everything like I just did and look through everything that throws errors at you and see, hey, what should I do with this? It should be pretty straightforward. One important note to make though is if you're moving over your functions as well, you're going to need to change around the class that you have these functions defined in, of course, because they're now in a new class. Again, should be pretty straightforward, but something that I figured maybe I should actually point out. And then we take this out of the tick function of our controller, and finally we put that into this tick function instead. We can take out the player character reference here, because that's just going to be this character directly itself. And now all of this code that we had on the controller before, we also need to change this, is now on our base magic character, meaning that both our player and our enemy characters are both going to be able to use all of this code much more easily than having to just duplicate everything around to a separate second class. We do have a couple of things to actually highlight here, and that is the things that are specifically related to inputs. Those we're not going to put on the base magic character, because the base of the magic character should be able to be used for both the player and the enemy version, and input is only relevant for the player version. So let's get the set shooting true and false functions also back on our controller. Quite bad form to have functions with the same name on two different classes, because that's going to get confusing. We're going to stick with it though, because why not? Let's put those back in there. But they're going to do something slightly different, because what we're going to do is we're going to first and foremost create the definitions for these two functions that we just recreated. And what we're going to do in these versions of the functions, I accidentally defined this one twice. We're going to make a base magic character pointer, which will be our character, and we'll set that to cast a base magic character, and what we will cast will be our pawn that we are possessing. If that ends up being a valid pointer, what we will do is we will use our character and we will make sure that in that base magic character, the set shooting true and set shooting false are public function, and we'll just run the same named functions on that actual character. And we can simply copy this over, and the only difference here will be the fact that we are running the set shooting false function. This is not ideal, I'll be the first to admit, but this is the easiest way to just refactor our code as it is right now. Now, the last thing that we need to do here is when we move, we want to set our movement rotation on our character because we don't have that movement rotation variable on the controller anymore. And that will be done in a much similar way here. So what we'll end up doing is we'll do this, and then our movement rotation will set in here, and that will be on the character. And that's likely not going to be in the public section either, so let's check that out. Both the movement and the shooting rotation should probably be in the public section too. And now we have our controller all set up to drive all the code on our character that can now be reused by an AI controller as well as a player controller. So while we have been working in our player controller so far for just ease of being able to literally do anything, this is a more scalable way because our code is now going to be reused by our enemies as well. Now, there's a few things here in my animation blueprint that don't work anymore because we're trying to get variables out of the controller that it doesn't have. So we want to get our is shooting from our character rather than our controller here, which again also feels like it makes a lot more sense to me. And we probably want this whole shenanigans to be changed around a little bit. So let me do that real quick. And pretty much we do anything that used to come from the controller. In our last video, we're now going to, we have that calculate movement blending. We're going to just get that out of our character instead. The wonderful thing about that as well is we don't want to do that, is that we can now reuse this, which way around was it again? I think blend forward was X and then the other one was Y. The wonderful thing about all that is that we can now reuse this animation blueprint for an enemy as well, because the enemies are going to have the same mesh, just a different material to differentiate them as enemies. All this logic all exists on the character, and our enemy is going to also be based on that class. So we can reuse a lot of this code very, very easily now. And just to see if everything still works, we can still move around. Our blending for our animations still works decently well. The only thing that doesn't seem to be working quite as I would expect it to would be our spawning in of the bullets. So let's check that out. Let's take the code that we have here that actually spawns in the bullets and put that into the if statement itself. I don't think that's the issue, but we might as well. And we'll set this active rotation in both cases. So if we do fire something, we'll return here. And if we don't fire something, we'll just set the actor's rotation and we will return a null pointer, which is a dangerous game indeed. And that seems to have fixed the issue for reasons that I don't quite understand, but it did. So now we're back to where we were at the start of this little video. Sometimes it's important to just take a step back, look at your code and think, moving forward, is this going to be the best way of having this code function? Is this going to be more in my way than it is worth me just not caring about, right? So if I didn't change this around in this video, there would be a large chance that it would end up costing me more time working around the stupidities that I have implemented so far than it would have to just sit down. I've been recording for about 20 minutes and just move this code around to a more sensible location and way of doing things. So now things are a lot more easily usable, a lot more scalable, and is going to save me a bunch of time in the future. So it is worth just having a video entirely just dedicated to that idea. I know this video is probably not going to get watched that much because it's boring and people don't want to listen to it and whatever. But I want everybody to be able to see where I put all the code going forward because otherwise people are going to get confused. So Thanks for sticking with me through this slightly more boring video. Next time, we're actually going to start implementing that AI controller, and things will get very, very exciting. Let's actually make some artificial intelligence. We're going to make Skynet. Well, maybe not quite that much. We're going to make a simple enemy that's going to walk towards us, and within a certain range that's going to shoot us. So we already made some things here in the previous video where I just gave a brief overview of the entirety of what behavior trees are like. So we have a couple of keys here for self actor, for can shoot, for player, and for the distance to the player. Today we're going to need to give this player a value. We're going to need to give and update a value to the distance to the player, and we're going to need to make a task that will actually shoot a bullet when all those requirements are met. So first things first, we want to, whenever we go through this selector, we want to update the distance to the player. So let's go into our C++ classes here and make a new C++ class, and that is going to be a BT service. We're going to just use the normal BT service as a base here, and we'll call that one BTS update distance to player. I want to give the distance a capital D, and then we're going to create that class, which will create our header file and our CPP file as we're used to. It's probably going to throw some errors at us because it just likes doing that. And here we're going to make a few variables. All of them are going to be UPROPERTIES, and we'll mark those as edit anywhere. And the type of variable is going to be an F blackboard key selector, and we'll call the first one self actor key. And then I'm just going to copy over what I pre-prepared for you all. We also have one of those. You can give them a category if you want to. Why not? We'll have one of those for the player key and one for the distance to the player. Here we can select the blackboard keys that we'll have on our blackboard and say you're going to read the position for the actor itself from this one, you're going to read the position of the player from this one, and then you're going to write the distance between those to this one. And that we're going to do in a function, and it's important that this is exactly what I'm about to paste in here. So I'm going to copy it over from a different project. It's going to be a virtual void tick node with the parameters uBehaviorTree components, ownercomp, uint8 node memory, and float delta seconds. This is the same as any other tick function on any actor, except of course this is specifically a tick function that runs on a BehaviorTree service node. So let's make a definition for that, and in that definition we're going to start by making two character references. Let's actually change these to a actors, because they could be pawns, they could just be normal actors. By and large, they're probably going to be characters, but might as well just make them actors, because there's nothing about the character specifically that we're going to need here. So we're going to cast that to a actor, and what we're going to cast is going to be our owner component dot get blackboard component. So that gets the blackboard component corresponding to this behavior tree. And from that, we're going to get the value from a key, and that's going to be the self actor key for our self actor, and that's going to be the player key for our player actor. And it's important that you get the selected key name, because it's all based on the names. It's looking up names and comparing those to each other. That's a little annoying though, having to type out those names, which is why we have this variable type that can just give us a drop-down menu in the engine. We do have a little bit of a problem here though, and that is the pointer to incomplete class uBlackboard component, and that is because we don't have that included. So let's get this include added in there. We'll be able to fix that issue very easily like that. And then we're going to check if both of those values end up being valid. So if we just put actors into both of those keys, this should end up being valid. Then I'm just going to copy over this line of code here. We'll have a float for the distance, and we'll calculate that with the f vector static function dist, and we'll get the self actor, actor location, the player actor, actor location, and then in our owner comp, again, that's a parameter from the tick node function, we'll get the Blackboard component, and instead of getting a value as object, like we did before, we will set a value as a float, and we'll set the value for the distance to player key, which is the key that we made here. And again, we have to use the selected key name and then put in whatever value it has to write to that key. Now, it's quite important to take a moment here and realize that because we're using all of this getting value as object and setting value as key, in the end, when we go back into the engine in a moment, we will be able to put in keys that don't match these types. We can put in any key we want into any of these key slots, meaning that if we put a object or an actor into this distance to player, it's going to try to write a float value into something that cannot take in a float value, and that's going to cause problems. So you do need to be aware of what keys you put into what key selectors and how you use them. Now, just as a little bit of an extra little fun thing is we can make a constructor for this as well. And if we make a definition for that, we can give this node a specific name, because there's a variable called node name, and that takes in a simple string here. And we can just call this update distance to player. That way we can see the name of the node very easily when working with it in the behavior tree interface that we were just looking through. And that is it for the code for this service. So when we put this on any of the nodes in our behavior tree, when we go through that node, this will run and it will update whatever keys we have put into it. Before you try to build anything to do with this though, this is a very important thing. You want to find your project name .build.cs. This is a C# file. And in here you will see we have a public dependency modules.addRange, new string, array, and then it adds a bunch of modules. In that, we're going to add in another module with the name gameplay tasks, exactly as it is right here. That will be needed if you are making BT services or BT tasks or decorators in C++. You'll be needing to add in that module. After you do that, you can build just like you can at any other time, and we'll remove the set default focus for now. And now we can add our new service, update distance to player. And when we select that, we get our self actor key, we get our player actor key, and our distance to player, which just happen to be set to the exact right things. But as you can see, I can put in any of the keys I want here. So do be careful about putting in the kind of key that you actually want to use there. Now, this service will run a certain amount of times per second. It will run as long as this selector is in the active path, but also it's not going to run it every single time, because a behavior tree, if it's just doing tasks and doesn't have any like wait nodes in it or whatever, can run a bunch of times, potentially tens to hundreds of times in a second. And you don't necessarily want to update all that information that often, because that's quite computing intensive. So what you can do is the interval between this running. So for the updating distance to the player, we actually want that to be run quite often. So let's run that every 0.05 seconds. So that will be 20 times a second. And we don't want any random deviation on that at all. So we're going to set that to 0. So now the self actor key will automatically be set to whatever actor this behavior tree is running on. The distance to player we are now writing to. The only thing we need to do is to make sure that the player actually has a value. And for that, we're going to go back to our base enemy controller. Just in the begin play function here, we're going to say that our enemy BT asset. For this, we will need to have a include for the Blackboard components. And the wonderful thing is, from an AI controller, you can just simply get the Blackboard components that this AI is using at the moment. And from there we can set a value as objects, and the value that we're going to be setting, we need to pass in a name here, so do make sure that this is the exact spelling that you use, and then the value of that will be, we'll be using gameplay statics for that actually. So let's include Kismet gameplay statics, and we will get the U gameplay statics function get player character, and then we'll use this as the context object, and then we need to put in a player index as well, which for now is just going to be 0. Now I think it's a good time to test whether or not any of this actually works. So let's go into our BP enemy here and open the full blueprint, just because I prefer this visualization, and see the AI controller for this class is going to be the base enemy controller that we've just made. And we should double check it has the BT basic enemy behavior tree. So in theory, when we place this into the world, which we have that one in the content folder, just place it into the world somewhere around here. I guess this one doesn't really need the camera now that I think about it, but we'll figure that out later. We can start a game and we can run towards it, and it doesn't do anything because it's literally just updating its own values. So let's actually open up the behavior tree here side by side with the gameplay, and this will be a little bit iffy because usually I do this on a second monitor, but we can see the self actor is BP enemy C, all this stuff. Can shoot is false because we haven't done anything with that yet, and the player is the BP player C0, so that is exactly correct. The distance is 325 units, and if we move around, we can see it is updating the distance very, very well. And now that we're standing right next to it, it's 68, almost nice. And when we run away from it, it increases. So, and you can even see if I show you right here, right now, we're under 1500 units away. 1500 units might be quite a little bit too much. So it should execute whatever is in this sequence, but if I run away, you can see it adds in this little red block over here, meaning that it now notes that, hey, this is no longer a true statement, so this decorator is now going to return false, and this sequence is not going to run any longer. So now what do we do? If we are less than 1500 units away, we want to shoot, that's fine, we'll make that in a moment. Otherwise, we're going to be moving to, and then we want to set that to player. So we'll just move towards the player until we're 1500 units or less away, and then we'll shoot. We'll actually change this back to 1000, and we'll copy over this decorator here and say that only when we are within 3500 units, which is quite a lot, will we be moving towards our player. Otherwise, we will just stand still for the time being. You could make a little system here where it just like patrols around to a random location. We're not going to do that right now here today. What we're just going to do is we're going to have these things stand still until they're close enough to us, at which point they're going to come running towards us, and if they're close enough, they're going to start shooting. A little note here, I did put this on the sequence. You can just put these on the tasks themselves. If you just need it to be one task, you don't need to put like a sequence or a selector node in between. That's entirely unnecessary. And honestly, I just spent about 2 hours trying to fix an issue, and I think it's just a bug at this point, because I have my behavior tree here, and it doesn't work until I go into that enemy controller and I change any random one of these options, like once player set. Has nothing to do with this entire behavior tree stuff, but when I change that, it then starts doing the behavior tree stuff, so I only have it chasing me around now. That seems like a bug to me, so I'm going to assume that you guys don't have that, because none of my other projects have that either, and it's the exact same code. But of course we want to add in that other task. So let's see if we can make that. So let's make a new C++ class here, And this one will be coming from the BT task. So the BT task node. And this will say BTT for behavior tree task, enemy basic shoot. For this, we need to put in a function with this signature and this return type that I'm going to add in right here. So that will be a EBT node result type execute task behavior tree component node memory. That is the exact signature of what we're going to need. This function will run whenever our behavior tree gets to executing this specific node. So, of course, that's going to be quite relevant. And for this, we want to first get the controller that this behavior tree is running on. And from there, we can get the actual character that that controller is then linked to. So the way we do that is we make an AI controller, and we just get that from the ownercomp.getAIowner. That gets you an AI controller back. And from there, we want to include our base enemy character, because we're going to make a variable for that, which we'll call simply enemy. And that will be a cast, and we've done this about 1,000,000 times, so I'm not going to bore you through it too much. And what we're going to put in there is going to be our controller's pawn. So we do controller, and then we can get pawn. And for that, we will likely need a include for the controller itself. So we include AI controller so that we can actually use that line of code, which is kind of a requirement. And now we have a reference to a enemy character. From there, we can simply say our enemy, we want to shoot bullets. Now, we need a rotation or a direction for what direction we want to shoot in, of course. For now, since we will be most likely chasing the player anyway, the easiest way to do that is we'll just use the forward vector for our actor as it is, and that should just shoot in the direction that we're facing in anyway, and that should work decently well. So get forward vector. And this task, while being pretty rudimentary, should really do the trick. So let's compile that and see if it works. All the navigation related bugs aside, because of course, hopefully you guys won't have those issues. Basic enemy shoot is now a task that we can put in. So we can say that, and we can put our decorator on it for the blackboard, and say we want to shoot only when our distance to player is less than 1,000 is what we're going to go for at the moment. It's going to go through and update the distance to player. I just had a different service on that, if you noticed, that I made during debugging, which didn't end up being actually needed. It's going to update the distance to that player, and then if that's less than 1,000, it will shoot. If it's not, it will move towards the player. And let's change the observer abort for this one to lower priority. That way, when this one becomes true while we are chasing the player, we will start shooting instead, and we'll stop moving around. So now when we start playing, we should start seeing him shooting into a direction in front of him. Then when we are far enough away, we should see him stop doing that. And he doesn't do that anymore, indeed, and those are all the bullets. And then we have that bug where he doesn't try to chase us unless we go into his enemy controller. And we change something around here, and now he starts to chase us, and you can see he starts shooting at us as soon as he gets in range, and now we are dead. So we really should put in some code to deal with resetting the level when we die, but for now that will do. So maybe 1,000 units is actually a little bit too much, as well as let's go into the enemy here and change its time between shots to something a little bit more reasonable, like 1 second. And let's change this to like 750, so that it just has to be a little bit closer before it starts shooting at us. And once again, I really don't like this bug. If I figure out what that bug is, I will put it in the comments below or in a future video, but for the time being, there's not much I can do. And now we have an enemy AI that we can shoot at, we have to dodge them, and we can kill them. So that's the basic idea of coding an enemy AI. We have used the behavior tree now, we've made a service, we've made a task. A decorator works in much the same way. So for now, that's going to be it. And next time we'll do something else exciting. I'm going to spend another couple of hours trying to hunt down that bug. And maybe, just maybe, I'll figure it out. And there will be a transition out to an extra clip of me explaining the issue. Some very, very good news. It turns out that actually I am just an idiot. And the reason that everything was going wrong is that in my enemy controller begin play, I forgot this little line of code. Super begin play. It wasn't running the begin play function on its parent class, which is the thing that enabled everything to work. So now you can see it'll try to move towards me and I can kill it, and definitely I do need to tweak some things like the camera on the player definitely needs to be a little bit further away. But that's a story for another day. I just wanted to finish this up by giving you guys the answer as to what my idiocy was. And on top of all that, something that I also should highlight is the player setup input components. I moved those to the actual player class rather than the base magic character class, as well as the whole set actor rotation from the movement and the shooting rotation. That also is now only on the player class rather than the base class, because the enemy is going to need separate logic for all that anyway. So that was also interfering with the rotation, and this just, I didn't need that on the other class and it felt like it might be interfering, so I put it on the player class as well. So we have something that halfway resembles a game. We've got an enemy that will shoot at us, it will look at us. I'll show you what I did to change that in a moment. And if we get too far, it will chase us down before it starts shooting at us again. So at this point, you can start designing levels and you're pretty much good to go as far as the game development goes. But there's a couple of things that I still want to show you and that you should really know about. But first and foremost, the way I made this guy always look towards is very easy. Unreal has a built-in system for that. You can set an AI's focus and that will just rotate the pawn towards that focus unless it's doing something else that takes priority. So if it's standing still, it will always try to orientate itself towards its default focus, which I just set to the player every single time we go through this selector. It's a little bit of a overkill way of doing things, but if you were to set the focus to something else, anywhere else in the behavior tree, it will always reset back to the player on the next loop. So today what we're going to do is we're going to talk a little bit about delegates, because that's one of the more important things that I haven't really covered yet. And what is a delegate? Well, a delegate is, if you're used to working with Blueprint, it is the C++ version of a event dispatcher. It is more or less, and I'm going to go into a blueprint here, things like the onDestroyed. This one, event destroyed, is an event that fires based on a delegate. Whenever we use the destroy actor node, that fires off a delegate that then fires off this event. So if we, for instance, say on begin play, we destroy the actor, and then on destroyed, we print a string, right? That means that immediately when the game starts, this actor is going to get destroyed, and as a result, it's going to print out a string saying hello. And we can see that is the case. So this is not directly hooked up to this, but still it's running that way. And that's the way it works in Blueprint, but we can also do that in C++. And there's a bunch of pre-existing events in Blueprints that you can use, like event possessed. That's also a delegate which fires whenever a controller possesses a pawn, and so on and so forth. So let's make a delegate, and for now because Unreal itself has so many pre-existing useful ones like undestroyed, that is what I would usually use as an example, but that already exists. So we're going to make a delegate that fires whenever a bullet is shot from any character, really. And then we're going to, on one of the characters, subscribe to a delegate and do something with it, right? So let's go into our base magic character header file, and the declaration of a delegate we actually do outside of the class. And I'm going to copy and paste the declaration here because this is kind of annoying to type otherwise. So what you want to type is declare dynamic multicast delegate. And then you can also put in a number of parameters. So you can make a delegate which fires a function with a specific amount and a specific type of parameter. So let's make one with one param. And then in these parentheses, we first put in the delegate name, which has to start with a F. So we say F on bullet fired delegate, something like that. And then we can put in the type of parameter that we want. So we want to know what actor fired this bullet. Maybe that will be useful information for us to have. So we can say a actor pointer. And then we do something a little weird because then we put in another comma and then we put in the name of that parameter. So unlike what you're used to in these functions that we have been using so far, where we have a function and there we do a type, a name, then a comma, then the next type, the next name, then a comma, next type and name, comma, next type and name. In making a type of delegate, you actually separate everything with a comma. So I also made a little typo here. Let's call that fired actor. And of course, end that with a semicolon. If you want to expose this delegate type to Blueprint for any reason, you can make it a U delegate. And the specifiers that you can put in here are the same ones that you can put into a U function. So that's, I've got a page open here. Blueprint authority, blueprint callable, blueprint cosmetic, blueprint implementable event, and so on and so forth. That's not what we're going to do here right now today, but you can do that if you would like to. And you might see some squiggly lines under this as an error, but you can see I can still compile this and this works fine. After a minute it catches up and now we have this delegate to work with. So let's add one. I'm going to add this into the public section because that way other actors will be able to access this delegate and say, hey, I want to know about when this delegate fires. So we're going to put this in the public section and we can just use this as a variable type now. And we can make multiple instances of it. So we can say on fired bullet delegate fired bullets. But if we wanted to, we could also make a second one and say this one is called bullet fired or something like that. And we could run this one in some situations and then this one in other situations. We're not going to do that, but you could, for instance, if you go into the CPP file here, in our shoot bullet function, we have two different paths here, right? So if we can fire, we execute all this, and then when we return, this last line here doesn't get executed. So we could have one of those delegates firing in here and saying, hey, I'm calling out, which means that whatever is listening knows that a bullet has just been fired. And we could put another one in here, which would mean, hey, anybody listening out, a bullet was just tried to be fired, but it didn't. If that's for any reason, for anybody, interesting information, there you go. I don't see a reason to do that, so we're not going to do that. But that's just an example of you can use this just as a variable type and you can have as many of these as you want. We're going to use this fire bullet though, and we're going to put that into our shoot bullets, and we're just going to put that into the if can fire is true. So at the very end here, we're going to say our delegate fired bullet dot broadcast, not broadcast. that would be quite nice as well. And that needs a parameter because that's how we defined it, an actor parameter. So we're going to just say this because this class is an actor, so it can just pass itself through to that parameter. That means that this delegate is now anytime we're going to fire a bullet, as the player as an enemy, because this is on the base magic character. Anytime anything fires a bullet, it's going to just scream into the void, hey, I just fired a bullet. Any other actor that might be listening out for that, which we're going to get to in 1 second, can then say, hey, when you fire a bullet, I need to do a thing, whatever that thing might be. And I can use whatever parameter is getting passed through here, so whatever character or whatever actor is firing that bullet, I have a reference to it now through this delegate, which is quite nice. Now, what can we do with this? Well, let's make something silly, something that we're not actually going to be using. But let's make something that increases in size every time the enemy fires a bullet. That seems pretty neat, right? That seems pretty cool. It seems real weird to me, is what it seems like. So let's make a new C++ class. It's gonna be a normal actor. It'll be private, and we'll say base weird growing thing. Do we need that name to be so long? No, and as a matter of fact, it's actually quite bad that it's so long, because now every time we need to reference this, we're going to need to type out that entire thing. And at this point, we're used to it. When we make a new class, for whatever reason, we need to go into our U project and generate studio files. And here we can make a new function. Let's put that under protected here. And we'll call that simply void grow, and it will be a very simple function. Because all it's going to do is we're going to set actor scale 3D, and we're going to set that to the get actor scale 3D multiplied by 1.1f. So it's going to grow 10% every single time. Well, actually, maybe we don't want to multiply it. Maybe we just want to add to it. So we will say plus 0.1. And the wonderful thing about this, by the way, is if you add a float to a vector like this, it will just add it to all three components. So now we're going to add 10% of its base scale every single time this grow function fires. But how are we going to link this up to a specific enemy? Because that's the thing. We want to link this up to a specific instance of the enemy. Or the player, for that matter. We could also link it up to a player. Well, first things first, in order to access all that, we're going to need to include the base magic character. And we're going to need a variable for that as well. So let's make a protected UPROPERTY, which we can edit anywhere. And that will be a base magic character pointer. And I do need to spell that correctly. And let's call this character to watch. And we'll likely need to forward declare this. So now we have a pointer to a base magic character. This can be an enemy, this can be a player, whatever. And we can say in our begin play, using that, we can now access our, what do we call it? Fired bullet delegate. And from here, we can say we want to add, what we want to do actually is we want to add dynamic. And there we just have to pass in, does it tell us a user object? So the object that the function that we're going to run exists on. So in theory, what we could also do is we could have one actor saying, hey, whenever this character does something, this other actor has to run a certain function. It doesn't need to necessarily be something that they do themselves. You can have a manager object that just listens out for specific pairs of actors. When one does something, the other one will do something as well. That could save you having to include certain header files in other header files if you want to prevent that. That's a possibility. For the most part, you would just run a function on the object that this exists on. And then we need it says the function name, but what you do need to put in there is the address of that function. This function actually will not be accepted. And I'm going to pretend like that was intentional, because I entirely didn't think about that. The only thing that you can put in here, the only functions that you can put in here are functions that match the signature of the delegate. So let's go back real quick to our base magic character header file. That's somewhere in here, surely. There we go. We make this delegate to take in an actor pointer. And when we broadcast it, it passes through a pointer to itself as that parameter. So now when we bind a function to this delegate, it needs to be able to take in that actor pointer. Even if we're not going to use it, the signature does need to have that parameter. So let's go back to our other header file somewhere around here. Add into our grow function just an actor pointer, and we'll call that enemy watched. Something like that. It doesn't matter what you call it. One important note though is that the function that you're going to execute through being linked to a delegate needs to be a U function. You don't need to put any specifiers in there, but it needs to be a U function, otherwise it'll just straight up not do anything. And put that in there as well. That will solve all the issues. It'll take a minute for this to disappear, but now all the errors are gone. So we can compile this and now go into the editor. We will add some meshes, but we'll do that through Blueprint because we don't need to have all that accessible through C++. So let's make a quick blueprint here and still ignore the fact that this is all very unorganized. And let's look for our weird growing thing class, which is a great name. And let's call that BP growing. We'll simply add a cube. I think that will do just fine. And in our top-down map, we'll put in this BP growing cube here. And we'll say the character that we need to watch will be our BP enemy. You note that it only has things that are children of the base magic character. So if we put in the player character, for instance, it will also give us this as an option in the drop-down menu now. While there's a bunch of other different actors there as well. I'm going to actually put you up a little higher, and you're going to watch this enemy. So now anytime this enemy will shoot, this thing is going to grow. And this enemy shoots quite quickly. So this thing is going to grow way out of proportion way too quickly. Let's take a look. So now we can see whenever that thing shoots, that cube is growing. And the reason this is very, very nice is because it eliminates having to have a two-way communication. I'm going to stop before that thing grows way, way too big. So this cube knows about this character, and it has an include to that class, which it needs to have in order to subscribe to that delegate. But this character doesn't necessarily need to tell this cube to do anything. And as such, it doesn't need to know that that cube exists. And it doesn't need to know all of the variables and all of the functions on this cube. And you can definitely imagine a situation wherein maybe 10 different classes all need to do something when a certain character does a certain thing, right? Maybe 10 different classes all need to do something when a boss or a mini boss dies, right? A door needs to open and barrels need to explode and money needs to drop and whatever. All those things can just look out for that character without that character needing to say, hey, you do this, you do this, you do this, you do this, and as a result need includes to all of those different classes. Because as we talked about previously, doing a hashtag include on top of a class pretty much just copy pastes the entire header file into that CPP file, meaning that it now has that entire class accessible. And if that's a class that's multiple megabytes big, every instance of that is going to take up unnecessary amounts of memory, which we don't want. So this is a good way to limit the amount of includes that you need. This way, it's just a one-street communication. This block needs to know about this character, but this character doesn't need to know shit about this block, so we don't tell it anything about that. And just to make things complete, we can go back into our base magic class header file, and this delegate can also be a U property. And we can mark this as being blueprint assignable. And now we can go into our blueprint and we can assign blueprint events to this as well. So if you, for any reason, want to do something in blueprint when a certain thing happens in C++, that's a good way to link those together as well. And now they just function as an event dispatcher. So we can say assign fired bullet. And there we just get an event which has the fired actor variable or parameter that we talked about before. And now whenever we fire a bullet, we can do whatever this custom event says. And of course, we can also do that from a different actor here, a different blueprint. So we can say begin play we can cast to base magic character because we can assign fired bullet, and now we have an event on a different blueprint that will fire whenever a bullet is fired. So that's also a good way of getting information from C++ to Blueprint sometimes. Between this video and the next one, I would like you to make a door that opens itself when a certain enemy is defeated, because I'm going to make that between episodes. I'm not going to show you how I make it. With all this information, you should be able to create that on your own. Last time we talked about delegates, and I challenged you guys to make a door that would keep track of 2 specific enemies, and once those 2 enemies had been defeated, the door would open. And that is exactly what I have made off screen right here, and I'm very bad at gaming. So both enemies have been defeated, now the door is open, and we can go on to whatever would be in this next room over here. I also made a little bit of a more twin stick shooter like level design to go with that. And with that, I do think that we're getting pretty close to the end of the C++ specific course. There's a bunch of stuff that we can talk about, like adding widgets, adding UI, but most of that, while parts of it are possible to do in C++ if you want to, I personally very much like doing those kind of things in Blueprints, using functions on the actors that exist in C++. So today I want to talk a little bit more about our health, because at the moment, if we go into our player blueprint here and we search for our HP, we find we have a single float with HP, and that's fine, but we're going to want to have a bit more in terms of stats. And we could just make a bunch of floats, and that would more or less work. But what we could also do is we could make a specific struct, a structure that holds a number of different types of variables that we can just look at as a whole, rather than every time we need to look at the stats, we need to look at one float and then the next and then the next and then the next. We can just get that struct, and that has all the information we need in it, which is much easier, especially if we're going to be displaying those things again in widgets. We're going to set this up in C++, but then we would use this kind of stuff most likely in Blueprint as well. So let's get into that and into our base magic character header file. Just like we declared that delegate last time outside of the class, we're going to do the same thing here. And we're going to be declaring a USTRUCT, in which we can also specify that this has to be a blueprint type. That way we can also access this through a blueprint, which is quite nice. From there, we can just make a struct by saying struct, and then this is kind of like a class. So we need to put in this generated body stuff here, and there we can just put in a bunch of variables. So we can make a public section and make a UPROPERTY blueprint, let's say read only for the time being, because we're only going to want to read from this most likely. But we also want to be able to edit defaults only, because we're going to be able to edit the health and the shot speed and the shot rate and all that kind of stuff on a per blueprint basis this way. And there we can just start adding things like the float for the HP. And from there, we can simply copy paste a couple of these, and we can say our shot speed, our fire rate, maybe something like our movement speed. And then at the very end, the bottom here, after the closing squirrely bracket, we do need a semicolon as well to end this thing off. Now, it's going to take a moment here to realize that we actually don't have any errors. And we need to give this struct a name. A struct type needs to start with a F. And from there you can name it whatever you want. So we're going to call this stats. Apparently stats was being problematic, so I just called it character stats. And now we have this character stats struct, which holds a HP value, a shoot speed value, which should be shot speed, but what do you know, a fire rate value, and a movement speed value. And let's go into Blueprint here real quick, and let's say on begin play we want to do something with that. We can make a variable of that type now in Blueprint. So we can say our character stats, and if we drag that in, we can split the structure up in, and it has new var before everything. That's a little stupid. But it has HP and speed and fire rate and movement speed. Now, instead of using a HP float, we can now just use a fCharacterStats variable as our stats. So let's go look through our base magic character. Somewhere in here we have HP. We're going to change that to being a fCharacterStats with the name character stats. That's going to be a little problematic because we're referencing HP a couple of times here. We'll change that in a second. First and foremost, in the constructor, we're going to give these things some default values. So we'll go fCharacterStats dot, and then we can say HP by default will be 50. Otherwise, all these will be by default set to 0. And we, of course, don't want that. So we also want to set our fire rate, our shot speed, and our movement speed. And we're not going to implement most of these things. It's just for the example at this point. So let's say our movement speed would be something like 800 by default. Our shot speed would probably be something a little higher than that, so 1200. Fire rate is, depending on how you implement this could be a number that is number of bullets per second, or this could be the time between bullets. I think time between bullets is easier to program, so let's go by default for 0.75, and then our default HP stat will be 50. Now, anywhere we were previously referencing the HP directly, we need to change that to our characterstats.hp, and it really is as simple as that. So we had our time between fire variable as well. We're going to replace that with our fire rate variable out of our character stats. And then we also want our shot speed. That is a little bit more involved to actually implement because we need to change something about our bullet that we're spawning here after it is spawned. And then we can try doing something about that real quick. So instead of making this an actor pointer, what we'll do is we'll just make this a base bullet pointer right away. And in the projectile movement, which we'll need to include. And if we're lucky, just setting the initial speed to our shot speed variable that we have here will work. But maybe it won't, depending on how things work under the hood. Like, if this is all done within one frame before this thing actually starts moving, this will likely work, but it might still not. And this needs to be in the public section of our bullet here. So let's change the projectile movement component. It would be better to make a getter for this, which is a function that just returns this that is public, while the pointer itself remains private. But for now, this will do fine. It'll work. So with a little bit of luck, that works. Otherwise, it would be a lot more involved and complicated, and I don't feel like going through that right now. So then on begin play, we're also going to set our movement speed with this variable that we have here. So at begin play, we'll get character movement, for which, of course, we also need to add yet another include, because we're going to need to access something from that component, which will be our maximum walk speed, and that we will set to being our character stats movement speed. And now we all have that stuff set through whatever this struct has in its values. So let's make sure that we have this struct as a UPROPERTY that we can add it anywhere. Probably add a default only would be fine here, but it doesn't really matter that much. And now we can see we have in our base magic character, we have our character stats, which we can expand, and it has all of these variables here. And if we go into our enemy, it also should have the character stats, and we want to set the fire rate here to something like 1.25 instead. And their movement speed should be a little lower than our own, so let's set that to 700, and then 850 for their shooting speed. They will have 35 HP, where the player might have 100 HP, for instance. And as easily as that, we now have two entirely separate characters. And again, if we were to make a UI, we wouldn't now need to get the HP and get the shot speed and get the fire rate and get the movement speed. We would just get the character stats. We can break that structure up in, like I showed you before, and you just have access to all that information through one variable. If you need certain values to be always coupled together because they're relevant to each other or whatever, it's generally a good thing to combine them into a struct just to keep your things from getting too cluttered. So now you'll be able to see this is my movement speed, and that is ever so slightly faster than their movement speed. And here we run into a little bit of a bug, and I'm going to keep this in because it's important to keep this in mind. If you're working in C++, it's very easy to just assume that certain pointers are going to have a value, and sometimes they don't. So what's happening here, I think anyway, is in our BT enemy shooting here, we just assume that this AI controller that works, and we have a reference to our base enemy character, and that's fine, and then that enemy will shoot a bullet. But what happens if, for whatever reason, between the minuscule amount of time where this task starts being executed and when we get to this shoot bullet function and everything about that triggers, this enemy is destroyed? And that's what literally just happened. That's why we crashed the game. We were shooting an enemy, it was killed just as it was about to shoot. So at that point, you're trying to access a null pointer, and accessing a null pointer will crash your game and the entire editor. So what you want to do is we want to put in just a simple if check for that pointer being valid. And you can just do that like this very easily. And this is where the node results also come in. I know that this is not what this video is about, but we're going to talk about it anyway for a quick second here. Because what we want to do is we want to return success when this has happened. So that succeeded. And then if the enemy, for whatever reason, is not valid anymore, we can return failed instead. And that will tell the AI system that, hey, we tried to execute this node, but it didn't work. So if that for any reason then would have impact on other decisions that have to be made down the line in the behavior tree, that's how you can use that. Again, not what this video is about, but good to know. So now that should be fixed, and I can show you that I walk a little bit faster. It looks like the shot speed thing might indeed not work the way that I might have hoped that it would work, so that's a little too bad. I killed both enemies, and now I can keep going, and I can design more and more levels and add more and more enemies. We can add a enemy type which walks faster, so we can say BP enemy 1, and change this one's material, and maybe we want to make this one slightly smaller. So let's make this one 75% the size, something like that. And then we're going to make him even weaker, so we're going to go down to like 30 HP, but we'll make his fire rate half a second, and his movement speed will be higher than ours. And now we've just designed an entirely separate second enemy, which is fantastic. So we can put that down, those are the materials. We can put like one of these down in the next room and then put an enemy there as well. And now we need to make our way through these first ones. We definitely also need to change up the AI because things were going through the walls there. And these things should also destroy the bullets when they hit the wall, because otherwise we're going to spawn in way too many different bullets that are just flying off into nowhere. But as a general just overview of programming in C++, this is how we set up things and how we can make a game. And it feels like the engine again is crashing. What is the issue this time? It's probably a reference to the player, because I think I just died. I think it's this issue here. I was trying to fire a bullet from a player that didn't exist anymore. So again here we also want to put in a null pointer check real quick and only execute this function if it actually exists, that object. So there's a lot of null pointer things that I probably missed, and that's the thing that I warned you about way back in one of the first videos in this playlist or this series or whatever, is these pointers. They're only real like complicated and annoying thing about C++, because this stuff happens, and it can also happen within Blueprint, don't get me wrong, but it happens a lot less. So you're going to need to get used to putting these kind of if statements before a function call like this, just to be sure, because you don't want players finding this out after your game is done. And you don't want to go back over all of your pre-existing code and hoping to God that you've just found all of the loose null pointers, because you're always going to miss something. So do make this a habit. In my own game, personally, that I'm working on, I have been trying to find an issue regarding a null value that's crashing the game sometimes for some players for like a month now. I still haven't found it because I was lazy, I skipped the step. I didn't put in one of these checks for every single time that I'm accessing a function or some information through a pointer, and now it's come back to bite me. So be better than me and do this. But I do think that is going to leave the C++ series here for right now. We have effectively made a playable game, and from this point forward, I think you should be able to figure things out on your own. That's not to say that there's not going to be any more C++ tutorials. Now that this series is done, I'm going to, moving forward, also make videos like I have been for blueprints, for specific features. I'm going to make C++ versions of those as well. And if all goes well, there will also be a next course, a long-running series going up after this. What it will be about is still up in the air, but it is likely going to be about network replication. And that's going to have a blueprint version first, and then I'm going to make a C++ version either after or parallel with that, depending on how well I can manage. So thanks for watching. I hope this has shed a little bit of light on working in C++ and coding and all that kind of good stuff. You should be able to figure things out going from here. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,